Hello, I am the Ronan Paul, and welcome to a twitch.tv/Ronan Paul live stream on twitch.tv/Ronan Paul. It's early here. It's quite early. It's so early that it really wouldn't make sense if I were already cracking a beer, would it? That just doesn't really figure. I'm going to have a beer. I'm going to have my first beer of the day, and hello, little magnets. Welcome to another programming stream. Didn't expect to slam in with programming streams, but my God, what we did yesterday, you know? So we looked into something yesterday, and by the end of the day, we're like, it was a good idea, but it didn't work out. Oh, it's going to work out. Oh, it's going to work out. Hello, Diggity D as well. So this nay. How you doing? How you doing? Let's just, we'll ease into it, you know. I want to dive right in, give people a chance to get here to see how big of a brain I've got. It's almost embarrassing because it's a little bit obvious, but none of you in chat realized it yesterday when we were programming either. But, so... What can I say? What can I do? I could, reintroduce SplitRP, just to fill a little bit of time here in case somebody's stumbling in who's never been here before. I don't usually programming stream. So if you weren't here last time, see, this is SplitRP. This is a tool that I've been developing in Python. This is the latest iteration of a tool that I've been developing for a year and a half or more. It's a year and a half, around a year and a half. I believe it was April or March of 2019 that I started working on SplitRP. It was intended to be an auto splitter for speedrunners so that you could be running live split. And then it would automatically send the splits in for you, and it was intended to make it so that we could do in-game timing as opposed to real-time attack timing, which makes the game fairer for people who don't have the fastest computer. It's not pay to win. Hello, Mac It Happen. Welcome. I don't mean to bore you with the same thing. I'm just trying to fill space so that people like Mac It Happen can show up. So this is the tool that I've been working on. Don't pay no mind to the UI and the interface. It was slapped together in order to prove a concept, and it's still proving it because I couldn't be bothered. But I've got it set up so that we can go over here. We can open up a video file that we want to test. And using configuration file over here, this is all my code, every lick of it, every scrap of it. Yeah, I mean, outside of standard libraries. But so using this configuration file, it can go through a recording of Cluster Truck. And it can identify when this run started. It can identify when you got in and out of the level, and it can record the time that you spent in the level separately from the amount of time incomplete that you were doing the run. And that's what makes time travel possible. That's the flux capacitor that makes IGT, in-game timing, possible without having to go through each of these things and cut it, which you can easily do on a segment, but on a full run, on a full game run, it would take quite a bit longer. If I go into I here, and just again, so it spits out all of the information about how long each level took by RTA as well as IGT and the wasted time during those levels. And at the bottom, it tells us, the full calculated time. This particular run, it's a very old run by Wolfie in Laser World, 157.161 or 3,516 frames. By IGT, 2 minutes, 1 second, 493 milliseconds, or 3,646 frames by RTA. But it really, really helps in the longer speed run if, say, you wanted to pull in somebody's first pre-30 run, and you wanted to analyze the whole damned thing, and not have to sit here and do it by hand and do 90 levels of cutting things down. You could just come in here, drag your in and out point, click the analyze button, and then it would handle it. It would do all of these things. And, you don't want to just trust the tool to do it right because the tool can be wrong. So I've got, it exports images once it's done, to a run log directory where you can go through and see that where it saw all of its splits, it shows you the frame before and the frame on, so that you can confirm that what was supposed to happen was happening, and that the timing is correct. And in ClusterTruck makes it very easy to just scroll through the list and see, yep, SplitRP seems to have done it right. But, this program has been running for, 35 seconds or something like that, and it's already into World 3. If I sat down and did this manually, I'd be here for a half an hour probably in total to get this done, maybe 40 minutes. It would take a long time and be very annoying to do. So that's SplitRP. It handles this for us. Hello, 02102. 2102. What's up? Currently in class, but why not watch? Yeah, I mean, learning. What's that about, right? You'll learn as much here. Nice work, Mr. Pun. Thank you, Snowman Olaf. This program is about to become 13 times faster. As put in the title, even though I know it's not going to be 13 times faster. It's going to be about 10 times faster, probably. But I realized something. We did some testing the other day. I'll get to it. It's going to be massively faster. It's going to be amazing. Hello, Noah. Dab, hey, who gifted me a sub? It was either the Light Guy 89. I can actually scroll down and see. Yeah, it was the Light Guy 89 gifted you a sub at the end of last live stream. Although, it's good to check because Milgrips gifted a fair whack of subs as well in the last stream. It was like 30 friggin' subs last stream. We were programming in Python. Not sending the right message here. A 10 times performance improvement is still a programmer's wet dream, right? That's why I'm live streaming at 11:11 a.m. here, because I'm excited to actually do this thing, and I didn't want to do it without you. I didn't want to do it alone. This is much better than school right now, isn't it? There's no COVID. I'm currently in England, but I'm currently in English, but Pawn is better. Oh, you're in English class. Ah, I see. Same, doing an English class. Everybody's in English right now. You can learn better language from me, I think. For example, the word cunt it's not as dirty as Americans think. You won't hear that from your English teacher. And Rex is here. Hello, Rex. Roy. Who the hell is Roy? But hello, Rex. Welcome. Did you come to see me turn SplitRP into a god-tier program that's going to do what it's doing right now in, it's 10 times faster, 1/10 the time? Did you come for that? Because that's what's going to happen here today. So I'm kind of waiting to see this thing complete just so we can say, so that's how long it took to process the full game. We're already into World 8 here. Would have been sitting here for 4 minutes. I've been jawing about nothing. And we're already into World 8. It's a massively helpful program for this kind of stuff for moderators of speedrunning leaderboards. And, just being able to do a job faster is one thing, but this actually enables IGT to exist for a lot of categories. ClusterTruck wasn't going to really have an IGT category, wasn't going to have IGT on the leaderboards until I started working on SplitRP, and then because I was working on SplitRP, other people in the community started thinking about other methods of doing the timing. Now we have a very accurate auto splitter that's directly integrated into LiveSplit. You just create a splits file for ClusterTruck, go into the settings, and turn the thing on, and boom, you're done. Simple as that. But none of the old runs were able to be processed, that didn't have that splitter working. So that's one, drawback. The other thing is that at least personally, I don't like the idea of relying on someone's local splitter to give the times. We have video recording proof of these runs, how they happened, what happened. And I feel like the official timing of our leaderboards, it's done. The official timing of our leaderboards should be based on what we can prove as moderators and not just relying on it looks like everything was running correctly on their end, So this tool allows us to have a set bottom scientific standard of we go by the frames in the video that you provided in order to determine timing. And there are issues that arise with that, and there are issues that arise with relying on the built-in splitter, and honestly, I'm very 5149 on this these days, whether or not to rely on what we call the built-in splitter, which is the live split splitter, or to hold our standard to what is provable based on the video evidence. Big weakness of that is different computers, some people can't record at 60 frames per second, some can. And that means there's a wider deviation for those runs. A 30 frames per second run is always going to have a slower timing according to SplitRP because, the event can occur in the space between frames and does, and that's not recorded and that's not, evidenced at 30 frames per second. At 60 frames per second, the event can still occur in the space between it. The game runs, faster than 60 frames per second. The calculations internally run faster than 60 frames per second. So BI is, the built-in auto splitter is the most accurate that we have. My only concern with it is that it's a trust-based system. We have to trust, and we can look at a lot of the, we can look at the evidence of the video you submit and be able to pretty accurately determine that you're using the built-in auto splitter. But it is a trust-based system. Everything that's timing then, if we're relying on the time that you submit from the BI splitter, that's based on, well, looks like from the video everything was going right on their end of things. And in addition, using that BI splitter, we're not checking all of the edges of every run that comes through, which means, there's opportunity for people to mess with it. They could mess with the code on their side, or they could, just kind of squeeze in, taking off a couple of tenths of seconds. There's opportunity for abuse in that situation. Whereas with this, once you've determined that the video is accurate, that the video is for real, you can basically just feed it into this program and get the true times that you have evidence backed over. I'm 4951. I could argue for BI very well. I could argue for VA, video analysis, very well. I choose to argue for VA because I think it makes more sense. Rex Skates, Pawn, I just finished a 14-hour deposition. You were brought up in it a few times. People just can't get me off the, I'm a worldwide phenomenon. Ronan Pawn, Your Honor, Ronan Pawn is a well-respected man who instructs people on the correct usage of the word cunt. I think that might have been just before you showed up, Rex. But makes my brown, what? Your brown hurt because you're writing an essay. I'm currently waiting to see if today's C# class will happen or not. Today's Python class is open and in full swing, so, I can't English. Nobody can English. Just thought I should use this. All right, you highlight as many messages as you like. That's SplitRP. I will now go into the magic that I have realized that we can do to make this program 10 times faster. So, yesterday, we were doing some testing. And what we were testing was the concept. I'm going to reduce this back down to just this. Is there a way to do, multi-line commenting in Python? I know also in this that if I could remember how to select... No. There's a thing where I could, create a deal there and then just put comment lines in front of all of it. I'm going to comment all this stuff out and we'll build up to it. So from the bottom to the top, we'll just comment all this new stuff out and go back to where we left off yesterday, because this was a little bit of testing to make sure that my theory was sound. So yesterday, we had 2 tests, basically. When I run these tests, what's going to happen is we're going to set up a timer, and we're going to run both of the image comparisons that SplitRP does. SplitRP does one style of image comparison right now, and it's this one. What it does is it takes images that it holds in memory. So if I show an Explorer here, here's the folder. Under the images and under cluster truck, these are the images that it's using to compare against. So it's looking for level complete screens, and it looks through all of these to see if any of them are a match, because you see that the level complete screen in Cluster Truck, it shakes, it resizes itself, it does all kinds of things. So if you want an accurate test, you either have to do a lot of samples or have a low percentage match. The low percentage match means you could get false positives. So we went with many samples. So there are 7 images here, right? 1, 2, 3, 4, 5, 6, 7. Yeah, 7 images for that. We've also got multiple images for detecting the menu screen in here. We've got multiple images for detecting the sort of pre-game start screen here. And then we've got multiple images for pause testing. And then we've got multiple images for level complete screens. And we've got a low light one, a highlight one, a dark one, a sort of mid-dark one. We've got steampunk. Each of these are things that it needs to be able to detect. And based off of these images of World 1, World 4, World 7, 8, and 9, it can make matches on World 1, 2, 3, 4, 5, 6, 7, 8, and 9. So much work has been done in figuring out exactly the minimum that I could get away with and still have a perfectly accurate sort of a system. And more work could be done, especially as regards the pause testing. But we really don't use it in Cluster Truck right now, so not a big problem. But yeah, so it takes one of these images into memory, and then it compares it to whatever is in the video file. So it compares it against the frame, and it's only comparing against things, that it gets into a sequence. To start the game, you have to go through the level select menu and then start running the game. Or you can go through the pause menu and start running the game, which is what the pause testing is for. But you have to go through a certain screen to start running it. So when you first start running, it's looking for the level select screen or the pause screen. And then if it drops out of those, and it drops not backwards, not to the main menu, not to the pre-menu, then it assumes that you've started running. And then it starts the main cycle, which is just looking for the level complete screen, all those 7 images. And then if you hit the level complete screen, it snaps into an anti-search, where it's now looking to see if you've left the level complete screen. So if it gets a match that you're still in the level complete screen, it goes, okay, I'm not going to do any other testing. Then, when it detects that that you're no longer on the level complete screen, it does some tests to see other places that you might be. I believe just the pause screen. But that's how it works, is it's looking for something, and then when it finds something, it's now looking for the absence of that thing, and so it's a search, anti-search, search, anti-search system. Hope it's not the magic in my pants. Ronan Pawn, I think you can use multi-line strings, triple quotes, for commenting, since they are ignored as long as they're not doc strings in Python. Also, do you write the verification images immediately to disk? Could speed it up more to store in RAM first and then dump that to disk once it's done. It is storing them and then dumping them at the end. And occasionally in testing, that's been a bit of a nuisance, and I've had to override it because I didn't want to have to do a complete test across an entire video. But yeah, that is how it's done, is it just stores them all up, filling up your RAM space with 1920 by 1080 images. Depends on what video you're analyzing. Could be a 720p image, but it does store them. Frackle, thank you for the subscription. Welcome back to the Big Dick Club. That's a year. That's a year of pawn, as Frackle puts it. Thank you so much. My God. Are we? No, we're fine. Okay. Just looking over at the live stream, I saw a red. I just upgraded OBS after, I've been out of date for like half a year or more. Once you have a system that works, don't change it until you've got problems, is how I've gone about it. And I was having some problems, and now we got the new version of OBS running. Hello, Nerd God. I'm digging the facial hair. You like it? Like that? Yeah, baby. Helps to hide how fat I'm getting. This shirt doesn't, though. Wait, I'm part of the Big Dick Club? You're part of the Big Dick Club, Noah. Well, it's all subscribers receive a certain amount of dick. So, the way that the testing works is it takes the image that we've got, the comparison images that are in this directory, and then it does an absolute difference comparison against what I'm calling the live image, the image that it's actually testing from the video recording. And the absolute difference is basically it lays the pixel values of both images over each other and then subtracts them, and then takes off any negative value that emerges. So it's always a positive value that you get out of it. And that becomes basically a difference map between the two of them. Because if you've got one image that's got, black here, and then you've got the other image that's got white in this pixel, then the black is 0, the white is 255. When you subtract it, you get 255 as the difference between that, the absolute difference. There's no signing, there's no negative integers with the absolute difference. So it tells you the difference between them. So it merges them together, gets the difference of every single pixel, and that basically creates a third image that is a difference map of what goes on there. And then we just sum up the differences. We add every single pixel value in that difference map together in order to find out what how different it is. And then we divide that against the total number of pixels and total the total value that it possibly could have been, flip it over, because it'll give us sort of an inverted result, but we've, subtract by one and something and the other. It's down here, isn't it? Or, wait a second. Similarity equals NP, some composite. You're not doing the testing. I need to put that back in. It wasn't actually doing the testing. So this is the formula for the first test. After it sums it all up, it then runs this little similarity formula, 100 times 1 minus, and that's how we flip it. And what we get is a percentage value. We get like a 94% match, a 97% match, or whatever it is by running that. Similarity equals NP sum composite. No. What you need to, so actually I can just get rid of that. And then it runs the summing in the formula there. So yeah, these are the two big mathematic operations that gets done. The absolute difference, where it takes all of the values of two images and subtracts them. We're talking about hundreds of thousands of pixel positions there. It's 1920 times 1080, and that's how many pixels it has to do, and it subtracts all of them from one another and then rips off the negative sign from anything that it gets back. And then the summing of every single value in that table is also a long... In computer, it's an intensive process. It's handled very, very lovely by the hardware, and so it's very fast in comparison to anything that I could write. But for our considerations, doing these two things are way more intensive than doing a division, a multiplication, all of that kind of stuff. These are the things that take a minute. So that's how it does it right now. The absolute difference, then sum it up, and then do a little bit of math on it in order to turn that sum into a percentage of similarity. What we explored yesterday was this concept, where what if, before we do this, complicated math here, that has these two things, especially the absolute difference method, what if we did a test to see if we should bother doing the harder test? And the idea was, what if I just summed up the values of both of these images? We just added all of the values together like we do at the end of the process for the other one, but without the absolute difference in it. We just take the sum of both of them and then see if they have a similar value. See if they're in the same, within a certain percentage of range of one another, so that we're getting, an idea of if these two images are alike enough to justify us running the proper test that involves this absolute difference thing in it. That was the concept, and what we found out was that summing is actually faster than the absolute difference, but marginally faster. It's barely faster. So we add all of those things up, and then we've got another formula very similar to the first here that gives us the percentage value from that as well. So I'm going to run that right now, and then we can see what the results were that we had yesterday. Run speed testing. And it's going to do this for 3 seconds each and just tell us how many times it managed to do it. So the absolute difference method, it managed to do 40,405 cycles of it. The sum test, it managed to do 42,736, which is a benefit, but it's not much. It's a very small deviation between those two numbers. If we ran it again, it might even be smaller. Wouldn't comparing only a small part of the menu screens, like where it says world, be somewhat better, or is it negligible, says Karacater, performance-wise? It is indeed, and in fact, that is how SplitRP runs, and in this testing, I'm also doing that. I'm converting the image down to a luminance grayscale, so just one map of brightnesses, and then I am also taking just a chunk of that area and looking at it. So we are looking at a smaller space than the entire image at once. When I take this out, it manages to do like a couple hundred, and actually this is slower when I take that out, when it has to process the entire larger image. The sum thing runs a little bit slower when it's got a larger data set. So that's where we left off, was we did that, and we found out that, like, this is faster, but not much, and then we integrated it into SplitRP to give it a test, and what we found was that because the difference is so negligible, it actually ends up taking slightly longer to finish, because while we're gaining a little bit of speed for every comparison that we can just dismiss and say, okay, we don't have to scan that with a longer process, when we do find something that we have to scan, we're now doing 4 operations instead of the 2 that we were doing with the absolute difference method. We do the absolute difference, then the sum. Now we're doing a sum, then an absolute difference, then a sum for each one that could be something that we need to test. So it was basically like, we're saving time over here, but it's costing us more time over here, and it's just not enough to really balance out to be a benefit. So we ended last stream with me going away, well, it was a good idea. Maybe it could be used somehow. I don't know. I'll see you guys later. 20 minutes later, it dawned on me. 20 minutes later, it dawned on me. Is this running on CPU or GPU? I don't know how, like, this is the libraries that are doing this are OpenCV and NumPy, and I don't know if they integrate directly with GPU, but I presume that this, like, absolute difference and these sum methods are straight to, like, the ALU, straight to, you know, arithmetic logic, and they might, you know, requests like that might be shunted directly to your graphics card. I don't know. I don't know if it's on CPU or GPU. It's in the library, and it's very fast, is all that I know. It's 2,076,000 or 73,600 pixels is how much it's doing. Okay, in a full 1080p image, is that what we're looking at? Wait, are you the cluster truck guy? I am, and this is me programming a thing that will be used for that is already used for cluster truck moderation, but that will be usable by anybody. Any game, pretty much any game that has a speed run can probably make use of this to enable IGT timing, as well as make it all just easier for moderation. And hello, by the way, VT Ninja. What's that little icon next to it? GLHF pledge. Good luck, Hammerface. Good luck, Hammerface, to you. I've made the same pledge. So that's where we left off. Was, it's not quite gonna work. And then 20 minutes after the live stream, I realized that I don't need to calculate the sum for the stored image. I don't need to calculate the sum for the stored image. We have the stored image. In my file handling over here, when we load images in, it it takes all of these images that we've got to test against, and it does everything that it's going to do on them in the first place. You know, we're not taking this image and cropping it and coloring it and, you know, applying resizing and stuff. If it's called for, when we load them in, we just do it, and then that's something we don't have to do at runtime. That's how I wrote it. I can do all of the calculations for this once for each one ahead of time, just like I'm doing for everything else, and have ostensibly a lookup table of values. That means we don't have to run that long operation of the summing that's going on in test 2. In test 3, I've made the sum a value that we can just look up. I've pre-calculated it as a permanent sum, and then we're going to run test 3 now. Yeah, that should do test 3. And this is only going to have to do the one sum of the image, the live image, the image from the video file, and then it's going to compare it against a value that already existed, because we can pre-generate it and store it in memory as a, table that we can look up from. So again, the first test, 3 seconds, it got done 39,722 times. 3 seconds for the sum test was 43,931 times, and the lookup table test conducted 87,100 times. immediately double. Immediately double because we don't have to do the sum. We went from 2 sums to 1 sum, and that's one of those intensive processes. So boom, just doing that makes SplitRP twice as fast as it is right now. And then I realized that we look at 7 level complete screens in just this one test, the one test that runs the most in the cluster truck thing. There are 7 different images that get compared against each frame. If it finds a match on the first one, then it doesn't bother doing the rest of them, but up to 7 comparisons are done. And those 7 comparisons are done for every single frame where there is no match, and it has to get to the end of them and say, okay, none of those are a match, I'm moving on now. 7 times we're doing that comparison. The way that SplitRP currently works, because it runs on this absolute difference method, it has to take the original image, or rather the live image, what I'm calling the live image, the image that we pulled from the video, and it has to merge it. It has to subtract that image from each one of those images. That has to be done. You can't pre-generate that value and do anything with it. It has to happen that way. With this method that works on the sum, I can calculate the sum of the live image from the video file once. If I know, if the programming, if the code is, given enough, if I make it smart enough, if I know that the next 7 things are going to use the same data, then I can generate the information once, and then I can pull all the other 7 values from the lookup tables. Hey, is there another test here? I think this should be test 4, actually. I can have it so that we only calculate once. We run 1 calculation in order to do all 7 of these. And if I were to do that sort of a thing, I think we're going to need you as well, then let's run the whole deal again, and I will move this up a little bit more so you can see all of the results coming out. So absolute difference, 38,000 times, 39 basically. Sum test, 44,000 times. LUT test, 87,000 times, double. LUT plus test, 552,000 times it was able to do it. That's 12.9, that's 13 times faster. Boom, baby. Boom! So I'll just walk you through what's going on here. The way that I set the test up anyway is we pull the sum value of one of these images directly from memory, because we can pull one of them from the lookup table that would represent one of these images that we've pre-processed and gotten the value for beforehand. And then we load up the live image, we do the sum on the live image, and we pull that similarity. And then I put us into a loop where it does it 6 more times, because we got 7 images to process, where it just takes the image to sum from the preloaded value. So I just wanted to have that in there theoretically to be like a memory access pull, because we're going to reach to a value that exists in memory and pull it over. So it pulls that over. We don't have to reload the image 1. We've already got image 1. We've got the same image 1 here. If we pull the image 2 from memory and then run this similarity test, there are no intensive processes being done here. So we do 1 intensive process, 1 table summing for 7 tests, and that means that we're doing 1 intensive process instead of 14, because this is an absolute difference, and then this is a sum. So twice, 7 times, every time we run that, that's 14 intense processes. And that's why that can only do it in 38,000, and that's why when we do it this way, we can do 552,000 tests in 3 seconds. Preload the 7 images into RAM. Preload, I'm already doing that. We're going to preload the value of their sums into RAM. Those are held. I'm going to preload the, when we hit the live image and scan it once, it's going to hold on to that until or unless it has to change what it's looking at. And I think I've already written something like that, and maybe it's been taken out because it didn't make sense for what I was doing then, but I remember already doing this because I realized that, we don't need to process the live image, this was written originally to run, while you're running the game and do auto-splitting live as you're running the game as opposed to be a video analysis post thing. So I realized if we've got that image and we're doing a bunch of tests that are on, that are the same test over and over again, that I don't have to take that image, crop it, color it, and scale it every time. We've done it once, we hold on to that, and then we compare it. So I took those processes out of the load. And that'll be somewhere in the main code there. All I need to do is add to that process, add to that logic somewhere here in the engine, probably in the multi-test, that, once you've generated the sum of that original image, of that live image that we're scanning against, hold that and feed that into the comparison algorithm every single time. Don't regenerate it. And that's what we do, and that's how this program is theoretically 13 times faster, but it's not going to be 13 times faster because of the original problem that we had yesterday, which was that we are going to be doing this pre-testing, which is going to dismiss a whole bunch of frames for us really fast using this method. But when we find something that we actually do need to test better, that's going to be slower than having just directly tested it, because we'll have run the fast test and then the hardcore test, So it's not going to be 13 times faster, but it's probably going to be more than 10 times faster than it was before. This is going to be incredible. And I just want to, before we get into this, before we actually start trying to code it, let's go ahead and run SplitRP one more time. And we're going to run it against the 720 test video. This is a 720p video, which means that it processes faster, less pixels density. We're just going to run it completely, from full to full, the analysis there. Let this run, and then at the end, we'll see how long it took to run. I will move you up there. Did dragging that change how long it took to... yeah, crash it. Crash it, we'll do it again. I want this to be up where you guys can read it. We're going to start the program up again. I'm going to move it there. File open. Because I haven't, done all the things that you would do with a UI to insulate the process from the visual and that kind of stuff. It's slapped together here. But we'll start the analysis again, and we're going to find out how long it takes us to complete this analysis. I'm going to write that shit down, and then we're going to start working on this thing. And our first results should be the simple results to get. Should be that it's 2 times faster. Slightly less than 2 times faster. Like 1.8 times faster or something like that. And then when we integrate the other one, it'll suddenly be 10 times or more faster. But so up here, we can see the video analysis took 22.025 seconds of that file. I'm writing it down. 22.025 seconds. How long it takes to process that. Just for later, once we've done what we need to do. Wouldn't it be easier to just use a fast programming language? Oops. I mean, all I'd have to do is learn, the ins and outs of a different programming language with different libraries, find libraries for supporting pulling in video stuff. Yeah, that'd be quicker. It would result in a faster thing, make no doubt. I'll mention, though, that there is a project that is pretty successful at taking Python code and converting it into C Sharp or C, I don't know, C++. It converts it to C, and then you can take what you did in Python and, create a much faster executable. But, if you've got specific weird Python-esque libraries, yeah, maybe there are troubles with it. But this will be massively faster when we're done with it. So, what we need to do, in order to just get started in on this, is number one, let's put the test back in. Well, what I'm thinking is, we found out last time that if I look for compare, we're using compare precisely once in the whole damn program, right there. So this is a public function. It's nice, but the way that this works is about to get a fair bit more complicated. So instead of passing values in and out of the function, I might just move this code directly in line to where we use it. I think it'll be easier to write in place and then probably end up breaking it back down to a function later. But I think it'll be easier to, you know, have all the logic happening in the same place and see it. C faster than C++? I have no idea. I don't understand the variance of C, C++ versus C#, C+, and C. I don't know what the difference are. Algorithmic improvements are greater than language choice. Yes, definitely in this circumstance. Not sure, but both are faster than Python. Using something other than Python would improve algorithmic calculations. Yeah, but 10 times? 10 times, my friend? I don't think so. I don't think so. Not on this scale. Not on this. So we get rid of. Yeah, let's do that. Similarity is equal to compare image shot. Let's move this down. So we'll pull the code out of there. Come down to you for image in test images. So shape is equal to image 1. So what do you play? We're using the term image and we're using shot. So we'll base that off of image. Color channel is equal to shape of the shape. Yep, that's fine. Depth is set by that. Sure. Composite is the absolute difference of image versus shot. And then we get the similarity out like that. And then we're testing similarity there. So I can do that. And that puts it directly in line, and now we can work from within the multi-test itself. Okay. And I believe that's the multi-test thing was me accounting for if we've got the same processing going on, then we can do it all, you know, at once without having to reload the image and stuff. Yeah, right here. If the last process that we did is not equal to the everything that we've did last time, if it's not equal to that, then we do reprocessing. But otherwise, we don't do it. That was one of the optimizations for saving processing time. Percent is equal to test match percent if match, else test unmatch percent. That's just deciding whether or not we're in the seeking for loop or we're in the trying to lose it loop. And then for image and test images, we loop through it. So all of the processing has been done. What we can do now is for tests and tests, if last shot proc is not different, or is different rather, than that. So when do I do the processing originally? I guess it's just happening there. Yeah, like search, give me processing with that. There's only one match. It's just happening here. Good. That's very simple then. So when we do this, we can also generate the one-time calculation. Oh, that's going to be... I thought I was going to do it backwards the other way, but this is going to... I thought that I was going to have to do the optimization of the stored images first and then get to this, but I think I can do right here that we're doing the processing on the shot. We can, you know, generate the value, the sum value, right here. One line. Boom. Oh, hello, a guy called Pi. It's just your cheer little magnets. I will get to it. Just reminded me to look over. Perhaps if you double current speed, it's technically 26 times. I don't. Yeah, blah blah blah. Looks a hell of a lot better than MATLAB at least. What? Who? And how fast will it be if it skips the test altogether, just to find out how much it can be faster? You mean just it doesn't do anything? Infinitely fast. What do you mean, little magnets? It has its drawbacks. I use Python for my job. It's okay. You mean if it doesn't do, like, the better test? If it just does the one test? We did test that yesterday, and found out that, it wasn't that much faster. I think it was slightly faster, but also it was inaccurate. You know, it was giving us false positives and things like that. So we definitely have to do the proper testing. In fact, we might find out that this version of testing needs to be configured with a different, like, percentage match ratio. I'm hoping not, because it just make it simpler for users to interact with and people to be able to write configuration files, or if I make a user interface for that, it'd be simpler if it just all sort of worked that way. And it seems like it could, where both of the tests can use the same percentage value. It seems reasonable. MATLAB is a garbage programming language my university is making us use to control robot cars created with C, C++. Oh, is it? Well, hey, if you're part of the first, right? Is that it? Robot cars and stuff? Well, it's robot cars, so it's not first. Did you do first? How many people in this chat room right now are part of first? You'd have to be in the US for it, and that's the something, 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 robotics, something, something. Competition and stuff. The loading of image and no test. Just loading and processing the image to see... I don't want to get distracted. I'm already distracted. So, what are we doing? We're going to do a... we want the summed... summed... sum... Well, let's just pull over my speed testing here and see what we're doing in this. Yeah, we're just going to sum it. Image 1 sum, we can just call it image sum. So image sum is equal to integer of np sum of image. Yes, if outshot is none, outshot equals shot, and then there's a percent. And then for each image in the test images, in the test image, in all the list of test images there, we can use the same, we don't have the shot yet? Or we don't have image yet? For image and test images. But we've got shot. Shot is processed, so it's actually what we want is shot. So after the processing, we've got image sum. Is that only going to exist here? No. That should exist publicly at least within this for loop. It's been a while since I've been programming on this, and I'm out of touch with where the variable spaces are going to exist. Like, it'll exist within this for loop, and the more when in this for loop, it'll still be there. We'll still be able to access image sum. So the test is to sum both of these things up and then pull the similarity. So let's get the similarity that way first. And so we've got, for each image, we got the shape of the image, the color channels. Like, a lot of this stuff cannot be done over and over again. I mean, they're little just definitions and pulling values that exist, so it's not a big deal, but they don't need to be done. We'll set all that up, and then here we want to conduct this. And what we'll have is we want the image sum minus the... Let's call it shot sum. That's better, because that's the original thing that we're testing against. So shot sum, we want the shot sum minus the image sum. And there we can get the image sum is equal to the integer of np.sum of the image. Shot sum might be referenced before assignment. It won't be, though. Because if this is working, I could put one on the outside if we have problems, but if this is working, then that shouldn't be an issue. If it is, then we can fix it. So that gives us the similarity there, and then the idea would be to have this little check now. We've got the similarity out of there. If similarity is greater than or equal to %, then I just have to sit here and think for a second about the idea of, if we run a test on one of these images, and we get a match on the... Yeah, this is smart too. So if we do the easy test, okay, the sum test, the pre-test, and we get a match out of that, we should probably just tell it, go ahead and run every single test that you can on this. Like all of the tests that are in the pack of tests in test.images. Go ahead and run all of those tests. Because we're looping through images that all match what we're doing here. Do they, though? All the time, across all circumstances. For image and test images. Yes, it will be part of the pack of the test pack. And not even the test pack, but the tests. Yeah. So if we find a match, because otherwise the way that it's going to go is going to run that test. It's going to say, okay, we got a match on this, so test against this and see if it's close. But instead it should say, we got a match on the pre-test, now run all of the tests because it's valid. Instead of saying, just test against the one that we're working on right now. No. Run all the tests immediately. Yeah. Get the one, bring that in. Because we're already sort of in that loop, in the for loop that's running all of those tests. Try CUPy instead of NumPy? I've never heard of CUPy. Is it purported to be faster in some ways or something? I'm also very, I don't even know which things I'm using from NumPy and which ones I'm using from OpenCV. There's a big crossover there in which one handles which thing. Similarity greater than equal to percent. And if I did want to tell you, then just run all of them. I mean, would it just be if similarity is greater than equal to 2%, then for if it found that's an interesting consideration. If for image in test.images, like I'm just gonna tell it to do it again. For image 2 in test images. No. This will be valid within this for loop and nowhere else. So that's fine. For image in test images, do this testing. So if similarity greater than percent, else outshot result equals true. And then when we're done with the whole thing, that's on the outside. So if we put that under everything, need to go in one more to be within the for loop. Does that make sense? You're going to say the variable is already declared above and that kind of thing. Yeah, maybe I do convert it, but just let me work it through, like, in my mind right now. It's NumPy, but for CUDA. Oh, really? Math plus 10 equals 10 maths. Indeed, the Phil Bear. Hello, Phil Bear. And, Das Luland. Hi, Das. Hi, Das. Confusing if KSP DOS ever starts showing up, but hi! I did first as roundtabler in high school. I was almost, I was on the edge of whether or not to get involved with first. What I wanted to do was actually like the 3D modeling. Didn't want to do the robotics, which actually now I would be way more interested in the robotics, but I wanted to do the 3D animations. I was playing with that on my own. Just 3D animations and stuff, so I was interested in that, but it just didn't happen. So we would do all of these things, we would do all of these tests, and then on the way out, though, on the way out of that for loop, we would want to break the loop that we're in because we just did all of the tests, you know? How do I do that? Python has a very cool system for this when you understand it. But I have to look it up every time. It's hard to get. And it might not be that complicated. Like, if similarity is greater than or equal to %. Oh, well, I could just put it right there. That's it. Yeah, it isn't the cool thing. Then I can just break. All right? And that will break the for loop that we're in, which is this one, where we did the if, and then we started this for loop, and we get through that, and then we break out of it. And if we found a match, then we break out of the entire thing by returning out of this everything that we've called here in the multitest. But if we haven't, then we get to the end of it, we break out of here, and we move on to the next cycle for tests and tests. Yeah. Yeah? Yeah. Okay. This might be it. This might work right there. Hi, genius. Stable or unstable? Still out. Court's still out. They're not. Doctor hasn't returned the results yet. Tried running SplitRP last night, and somehow it managed to cause a blue screen of death. Was it? Jesus, any version of it shouldn't do that. BMA dev. But was it the rebuild branch? Was it the latest from the top of the list of releases on GitHub? Or did you download the code? Or the rebuild? Yeah. Yeah, I don't know. Sounds like RAM. What? Because a blue screen of death, you're immediately going to jump to a corruption of memory? Because that sounds, yeah, that's probably. But let's just try running this. This might solve some of the, like, this isn't going to be the fast version. But let's see if it runs at all. Okay, so we're not going to know until we start doing a process. Okay, it's running. And it looks to be getting the splits correct. Yeah. Okay. All right, so it's still running, and we're doing the pre-testing now. I want to look at that again, just to make sure I've got it in right, but hell, it seems to have worked. And this came in 21.5 seconds instead of 22 seconds. We'd have to do more testing to confirm that it's, actually running a little bit faster, but that's already a good positive indication, and we're nowhere near the place where it's going to make anything really fast yet. But it worked. Did it give me the correct value? 157.1 and 201.493. Yeah, those numbers seem familiar anyway. I'm pretty sure that's right for that file. I've worked with it a lot. But yeah, that's good. Let me just, God damn it. Well, I keep putting it down here, and then I'm on the verge of not being able to grab. You know what? Grab from the top, make it a little smaller, pull it up, and quit being stupid about it, and then you can do this. So yeah, video analysis took 21.5 seconds instead of 20. So good. And it seems to have worked correctly still. So let's just go back over this and make sure it's doing what it's supposed to be doing. So we get all these values, and then the first test we do is we compare we get the image sum. So this is like the test image. We get the sum of that. We've already generated the sum for the shot up there. We test them like so. And then if the similarity is, greater than or equal to, then we do all of these tests. Otherwise, we just keep looping through here until we're done with all of the images that are in the test. And then we break back into this loop for tests and tests. That all looks to be correct. And it seems to be functioning correctly. And it seems to have saved us some time. Let's do it again. File, open, see if it actually gives us the same, slight increase in performance here of a 21.5 second time instead of a 22.0. Even Python isn't bad enough to blue screen a computer from image processing. Oh, you think that it's, you think that it might be a local hardware issue as opposed to my program fucking up somebody's computer? I mean, I like that explanation suddenly. I wasn't even thinking about it that way, but sure. Yeah, that's probably it. You know, it sounds like you need some new RAM there. That's what you need. It's not my problem. I didn't do anything to your computer. So that, that, 20.8. 20.8, no, 21.821 instead of 22.0. It's at least running right around the same speed. You know, both of those are faster. Both of those are faster than what they were in the other method. This is it, so it's doing something already, and it hasn't even gotten the benefit that we're going to give it, because the big benefit here is going to come when we don't do this anymore. When we don't have to do this sum. We want to be able to pull that sum out of memory. For that, we need to go over to file handling, and we need to go when we load the images in. The way that this works is when the program starts, when you load in a video, when you load in a pattern file. I can't remember which of those is true, but probably 2 out of 3 of the things that I just said is correct. We go through, we get all the values out of everything, and then we actually apply them directly to the images, and the images that I store are not the full-scale image. We store the image as it's been cropped, as it's been colored, as it's been resized. We store that image, and we hold on to that, and then when we go to test, we just grab it and merge it together for the full test. What we want now is to also, when we bring these images in, conduct the summing of their values and store that as information along with them. So we've got the image itself. Is there like some kind of package for each image that I can store this information alongside of it? That could be a big, you know, nuisance kind of thing if there's nothing for me to store it in. We got file in self.imagePaths. All right, so we're just looping through the list of images, and then we generate an image, and then self.images.append image. Okay, no, this shouldn't be that hard. So if we've got self.images and that's a table, I could add a dimension to that table and just store the value next to them or alongside them. Make the images append as the 0, 0, 0 and 1, 0, and then have the data as the 1, 1. Or I could just create a completely separate list, which is probably just as well. But okay, so in here, once we're done with all of the processing, the last thing that we want to do is we want the image sum, np.sum of it's just of the image, right? There's nothing more complicated to it than that. Just get me the sum of that image. And then if I go back to SplitRP just to check, np.sum of the image. Oh, we want to make sure it's an integer. I knew there was something that, wait a second. So the int is around everything. Integer of the sum of the image. And then that forces it to be an integer, which saves us from those scalar ulong out of reach corrupted errors. Yeah. So that gives us an image sum, and then I just need to do something with the image sum. So self.images append image sum. Yeah? Unexpected argument. Can I do this then? And append it as, so there will be a 0, 0 and a 0, 1. Now, if I do that there, then that means that I have to change the interactions with images in the rest of the program. How many images do we have here? So, .images. In test.images, for image in test.images, it's just these two? Fucking brilliant. God, my code is so fucking tight and clean. I go to change it, and it's like, it's not a mess that I have to, undo. For image in test.images, in fact, for, this is not going to be image anymore. This is going to be for, image, well, no, for image, comma, image sum. Maybe? I always get confused because Python, it lists, and then there's dictionaries, and it just seems like there's too many goddamn ways to access basic objects. Hello, my browser won't start. Support connection. Yeah, buy a new computer. Yeah, bring it in and we'll swap the motherboard for you. This happens a lot every day. Yeah, you gotta. There's too many gremlins in the carnival. This rainbow transmission drive. It's got you're gonna have your gluons passing through the field. Is what you got going on. The fluctuations in the photon inhibitor are caused. You just bring it in and give me $700. I'll get her fixed for you. Hey, Paul, how's it going? Hello to the light guy 89. It's going very well. We're getting on swimmingly. So that could work for image and image sum, and then I don't need to do this anymore. We just have the image sum. But again, then we have to do that down here for image. Well, no. Well, yeah, for image sum. But we're not going to use image sum at all in this testing. Why stream so early? Because I was excited about this. Let's see if that image sum thing works out. It seems like too easy. You know, I expect to see some errors here. None yet. Here's where the error comes. It's working? How could it just be working? That doesn't make any sense, god damn it. And it's doing the splits the correct time. I'm not happy with it not running 1,000% faster immediately. It's supposed to be twice as fast, I think, at this point, right? No, it's supposed to be a lot faster. Video analysis took 21.0. Yeah, it took 21.0, which is faster than anything that we've seen in testing today anyway. We started at 22.0, we had a 21.5, we had a 21.8, now we've got a... No, Pauling. You keep reading incorrectly. It's a 21.0, which is also faster. We had a 21.5, and we had a 21.8. 21.0 is the video analysis took there. But if we're now pre-doing the image sum, and we're pre-doing the shot sum, or at least we're doing the shot sum the one time that we need to, this should be massive time. This should be masses faster, is what it should be. The break is in the right place to break us out of that particular for loop. I can't believe ostensibly we're already done. I thought this was going to be like a big thing. I'm going to have to redo how file handling works in SplitRP, but unless I'm missing a trick right now, we are currently doing this. We are taking the shot sum once for as many tests as we need to, so long as the processing doesn't change across, various things. So that means that we can do... we take out 7 processes that would be generated otherwise by doing that. Then, what? Your mother. Then, we are now doing the similarity test, the absolute of the shot sum minus the image sum, divided by the depth. So this test is, we get this once, and then it doesn't do anything else for all of the testing that it might do within here. If it finds a match, it dumps us into this one, and this does exclusively like the big test, the abs diff. And the sum of the composite of that abs diff. So that all has to happen. That's the big test. That's the important one. That's the one that makes time travel possible. And then this, and then if you do all of these, and it didn't find a match, then we want to break out of this for loop. Because we've just done what this for loop would have done for this test, but we did it for this test because we found a match. That's correct, and yet it's not suddenly running 10 times faster. Well, I think it's time for... We've been here for an hour and 11 minutes, and we've run into a unexpected little why is it not workings issue, which is always a good time to step away. Let's take our first 7-minute break. I need to pee, and you do as well. When we come back, we'll try and squeak out some more of that genius juice that's in the title and see if we can't figure out why it's slow. Is there some process in here, you know, like just loading the image from the something or that we need to address? Have we not been slowed down by this? Is there something, maybe it's the UI, you know? There could be those concerns, but yeah, we'll step away, we'll come back, and we'll keep going on it, because I'm excited. This should end up working out for us very, very well. Stick with me across these 7 minutes. Don't go anywhere. Pawn that out. Hello, I am the Ronan Pawn, and welcome back to twitch.tv/Ronan Pawn live stream, where Nerd God is lying because of a preconceived notion that he holds so strongly that he can't see what's going on. Welcome back to the live stream where we're programming in Python. Nerd God did a thing that made it slower in an attempt to make it faster. No, it's faster. It's... okay, 21 is a lower number than 22. We do have to establish that as a principle, Nerd God. It is running faster, it's just not running 10 times faster like I projected. And honestly, if you keep on about, fucking Python and shit like that, like, you can bad talk Python, but, like, have some sense behind it. At this point, you're like, well, it's just that Python's slow for this. I'm trying to figure stuff out. Don't flood my chat with nonsense. Any rants I missed? No. What is SplitRP? Asked Pludgy. It is a video analysis program for helping moderation of speed running. So this is a speed run. It was submitted long ago by Wolfie. If I put it into my speed run and click the analyze button, if I put it into SplitRP, it goes through and you see a little marker there. It's leaving indicators of when we hit the level complete screens and when we come back out of them, and it takes the timing automatically for us and removes the time that we spent on the level complete screen in order to give us in-game time readings that make the speed run itself fairer and more competitive on the leaderboards. So these are all the informations of the levels themselves individually, and then the total comes out, and we know that the IGT is 157.161 and the RTA is 201.493, and that 4.3 seconds were lost just to being on the level complete screen. So it just basically does the job of timing a run for us, as well as, you know, giving us IGT, which we weren't capable of without a system like this. We were capable of it, but it takes so long to do a single run, it's non-viable is what it is. No rants as of yet. No big ones, at least, isn't there? Well, that was a mini rant that I just threw at you. So that's what SplitRP is, and this result just came out. It got done, it processed that in 21.6 seconds, and again, before we added this code, it did it in 22. But I'm expecting to see this be about 10 times faster when we're done with it. And we've just put everything in. My brain tells me that we've got all of the things that should be making it faster. And taking the live stream break didn't, hit me with any extra things. I think I need more information. And so for more information, what I'd like to do is establish a counter. So, let's have a frame count. Frame count plus equal to 1. So how are we going to do this? When we go into the multi-test, we can have it be... it's not frame counts, though. Well, it is, though. Yeah, it is. So what I want to do is we'll have frame count equal to 0. And then we'll have a counter, and I want the counter to exclusively be, it counts up if we didn't do this at all. Is that the idea? Yeah, so if we didn't do that, then it would be on the outside of the break. No. So we do the test, and then if similarity is greater than or equal to %, we do that. But it's got to get through the whole, all of the tests before we can do it. So actually, it would be once we fall out of this. If we fell out of this, but I need it to not, it could do this and then return from in here. What I want to do is I want to count up how many times we actually avoided doing this test process entirely for one of the analyses, so that we only ran this test over and over and over again, and we never dropped into here. That's what I want to see. That's what I want to count up. Ren Phoenix with a subscription. 5 months on a 4-month streak. Right now you look like Mirror Universe Pawn. Does that mean I'm not evil or am evil? I think basically Mirror Universe me, because I'm sort of just right on the edge there, would also be right on the edge. So, yeah, I'm just me with a beard. Thank you, Ren Phoenix. for the subscription. Welcome back to the Big Dick Club. So how do we get that? Where do I throw in the counter for this to make sure that we never did the similarity test across the whole thing? Because we could do them and then go all the way through them, and then that would break us out right there, which would mean that we wouldn't get down here to hit the frame count. But the problem is, you know, if I put this down after the break outside of that test, we're going to count that for each one of these tests, which is happening on more than one frame. So it's like we want the test out here. Okay, so we do a Boolean. We do a Boolean flip, right? So if similarity is greater than or equal to %, then skipped equals false. All right, and then up here we'll have skipped, and it starts out true each time. And that's for the whole multi-test, which is going to run all the tests, which is going to construe like, yeah, it's going to be one of those. So if we ever run this test, it'll be switched to false. But if we get to the end of this whole thing, which would be for test and test, last proc, before we get to the return, right before the return, we could say if skipped then I want you to frame count. Here's the thing. We need to get this value out of this function. So we'd either have to write to a variable that that exists outside the function, which just creates issues, or we want to hand it out as part of our return. So frame count equals 0. Like, I don't really need it. In fact, what I could do is just use skipped and not do an if check, and then we don't need the frame count. Skipped is equal to true. And then whoever's calling the multitest, because we need to add this up and then have it in the log. Could I just... where do I hand this thing out to? If skipped count else break. What I'm thinking is we started out as true. If it gets to the end and it's still true, then a true is a 1, instead of a 0. So I can kind of just add skipped to something, but I need to hand it out of here, out of the multitest to something, or access an object that exists outside of it. And I'm just kind of stuck in two worlds here because I feel like I go down the one path and I know that it'll work, but I go down that path and it just seems stupid to have created a fucking class object that'll grab a number. I just want to hand something out to a counter that I can print out later. It's been too long since I've Pythoned, and I really kind of don't want to, have the return. Let's see, who's calling multitest? Control F, multitest. You call it. So there's two places where it's called. Match equals multitest if match 0. What? Okay, so match 0, and then I could just append it. There is what it looks like. Her match is equal to self.multitest self. Like, it's not that I cycle through it, I grab them directly. Alright, if that's true, then it's probably the easiest thing to do to just, where am I in the code anymore? Skipped equals true. Down here, I can just hand out skipped on the end of that. Let's see if the program doesn't crash before I get too far in programming around that solution. And I'll see if it just isn't using that value and it doesn't screw anything up for it to be there. We'll find out. Can't just make a global variable? maybe it's a Pythonic thing of just not knowing, you know? I've been not in Python for a while, so if I make a I don't, basically I don't deal in globals. Everything seems to have worked. It took 21.2 seconds. It still gave us the correct results. The logging looks unfucked. So yeah, I can hand skipped out to here. And then I'm just in another thing, aren't I? Aren't I? So if I do a global, isn't it just global skip count, we could call it? And then what do you got there? Over because undefined at the module level. All right, because we're allowing ourselves to access it in here by saying it from within this function that's within an object and all that kind of stuff. So if I do it like that, and then skipped equals true, and then we go back to the concept of at the end of this process, but before we do the return, which should be on this line, if skipped skip count plus 1. So then we need the skip count to exist, and I'll put it at the bottom. Screenshot, settings, files, engine. So skip count equals 0. And then at the end of the process, like, we dump out this log video analysis took as the last words that we see. So where does that kick out? Video analysis took there, and then pop splits and all that kind of stuff. So from here I could print skip count, and do I have to make that global within this? Potentially. We'll find out just by running it. This is why I didn't want to do it, because I don't know fucking globals. He's negapawn with the Godai. Because it's in a loop, I see. It's just confusing. I don't know. Like, if I'm breaking it in, breaking it out, how much I have to do. We'll see if it, like, fails on what's skip count when it goes to print it at the end of this process, which will happen down here. It printed 3,549. Good. Okay. So we can do this ourselves, but for the fun of it, it seems to be working. I wonder if I even had to, invoke global there. If I can print it from here, maybe I didn't have to. But print skip count. So we'll do an f print. So shoe in here. Let's see. Frames skipped count, and then which is, I want to generate a percentage, so that would be 100 times skip count divided by total frames. Are you gonna clear out all those red things? You're not? What's your problem? Unresolved reference skip count. Is that... Okay, now it's got a problem with it. This is why I didn't want... Alright, so we'll put global skip count. We'll invoke it here. Come back down and see that it no longer has a problem with it. What am I doing over here that I've fucked up? So the print and the F and then U, times skip count, you need that. No? Okay. Okay. That should go. Maybe. Now that I think it'll go, now it fails. All the other times I'm like, this probably won't work, and then it worked. So we run it through again. Just pull you up. Let it keep running. And see how many frames we were able to avoid. Calculating. I meant to put a percent of 92%. 92% of the frames were skipped? Really? Let me just change that one more time. So where's that printout again? It's right here. 100 times we wanted that, and then I want that, and then I also want the percent sign, and then we'll do round 2. So that should round it down to, in this case, 92.93 is what we should see there. But what I wanted to add to it as well was of total frames. And see if that number is also correct. So file, open, 720 test, analyze yet again, and let her process. Your math is ass backwards, is it? $3,549 of 3,819 frames were able to be analyzed without going into the deep one. That is exactly what I wanted to see. I wanted to see it just not bothering with most of the frames. Over 92%. I believe that number now. I have to look at it again to make sure I'm doing it right, but that seems believable, and I was hoping for that. So why is it still taking as long, not as long, but nearly as long as it used to? We've only saved a second off of this process. Why are you multiplying by 100? Should you not be dividing for a percentage? Skip count over total frames gives us a value that will be, between 0 and 1. So it'll come out as 0.92. I multiply by 100, and then it turns it into 92. It would be 0.9293, blah, 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 blah. I multiply by 100, now it's 92.93%. And then the rounding to the second decimal just makes it nicer to look at. But yeah, it looks like it's correct. So why is it slow? I'm glad that we know that now. I think I'll leave that in. I'll redo it here since I've made it like a language kind of a thing in the second half, which will be the skip count. Frames skipped of total frames. It's like testing. There. Okay, but that just does leave us with the confusing issue of why? Why isn't it like bajillions of times faster then? Why isn't it 10 times faster specifically? 13 theoretically, but about 10 in practice was my guess. Why not? We're in the multi-test, yes. So if the last proc test prop boop do shot equals processing, we pull it in. So this is saying if we can't use the same information that we used last time because it's changed, because the test is different than the last test that we conducted, then we will do the image processing that needs to be done on the live image, the shot from the video that's coming in. And now we're calculating the sum of that for the sake of comparison as well. These are the things that happen if we have to. Otherwise, we don't do it. If outshot is none, outshot equals shot. I think that's for saving shots to the disk. Because just in case you weren't here before, I'll show that the way that we can verify that this worked was we go to the run log, and it shows me, it saves all of these images to the hard disk, and it just overwrites them as it goes. But so these are all of the images that were generated by that testing, which shows us that it found the level complete screen the first frame that it could, and it found that it had left it the first frame that it had left it, and the same for the level complete. So we want to see that kind of 2-column thing of in, out, in, out. And if we do, then it worked. So it is working. But why is it not suddenly a lot faster? Because we're only doing this the one time that we need to, so long as it doesn't change. So that should be one sum for 7 loops of looking for the level complete screen, where we used to do, one of these. We used to do a sum and an AABS for each of them. Or we used to use sum and an absolute difference thing for each of them. We're only doing that once, and then we're able to use that value 7 times. Similarity equals 100 times 1, the absolute of shot sum minus image sum. The shot sum is what was generated here. The image sum is being pulled in, so that we don't have to do that because it was done when it first loaded the images in. It should just, like, the amount of heavy processes that aren't being done because we're doing it this way should just fucking overwhelm it. Just fucking overwhelm it. Feel another coughing fit coming on. Oh, really? My bad. I thought you just wanted to see something different. Huh? Oh, for the percentages? Yeah, we should be 10 times faster right here, right now. My only thought is that, am I somehow, because I've nested this, is this break not kicking in the way that I think it would, and so we're actually doing this over and over again? Like, this break happens outside of the for loop, so this break doesn't break that for loop. Break doesn't break if, right? Can break be used to exit an if? Python. If break? It should just be nested loops, but there's some weird things with loops in Python that are very brilliant once you understand them, especially around for if testing. Break and continue statements can alter the flow of a normal loop, iterate over a block of code, until the expression is false, terminates the loop containing it, so enter the loop, yeah, if condition break, and then that would break that. I just, it doesn't make any sense to me that break would get you out of an if statement, but, continue. How does continue work, actually? Continue statement is used to skip the rest of the code inside a loop for the current iteration only. Loop does not terminate, but continues on with the next iteration. Right. There's some interesting things, though, if you look into it for breaking loops. Continue gets you into the next iteration of a loop. I think, in particular, what I'm remembering is if you're in a loop that's nested in another loop that's nested in another loop and you want to break out, Python handles that in a way that isn't, like, intuitive, but it does give you a way of doing it very cleanly and very, very nicely. But it's a little bit, if I recall correctly, whatever it is, it's kind of feels like it's on its head. Like, you can basically turn the for loop itself into an if statement or something, and then that condition of that for loop you can then analyze to see whether you should break out to the higher level. It's very interesting. Print when the break is supposed to happen to check if it's breaking. I don't doubt that it's breaking. I wonder where it would be breaking to. Yeah. So how do I confirm that it's breaking out of this? You know? That's what I want to confirm. Seems convoluted by slightly useful, I'll admit. The thing with the continues. Yeah, it's weird to wrap your head around, but once you get it, you're like, oh, thank God somebody finally like dealt with this issue. I don't know if there are other ways in other languages to do it, but that whole concept of being in a loop that's in a loop that's in a loop, and you want to break the whole thing, but you don't want it to return. You want to get up out of these loops, but still within other loops and stuff like that. So, I mean, this break is happening outside that for check. So, if similarity is greater than or equal to %, we do all of those things, and then I want, as part of the condition of this if statement, if we did all of them, then break out of this loop. Because we just did everything that this loop used to do. It's weird to have this nested in itself, but it seemed viable at the time, and it is working. But we want to stay in this loop, so we break to that one, and then we're still in here. I just can't think of any easy way to confirm that that's what's happening, and I can't really come up with a reason why it shouldn't be happening. It looks correct. Do a print before and after, and where you want the break, to see if it does it. You gotta realize this is happening, like... It's happening 3,819 times, and actually this part of it is testing so that, like, times probably 10 or so probably like 30,000 times. But if I did put a print in there, then I could at least, like, maybe scroll up to the top or scroll up to something and see. I could give it a conditional, print if this is the condition kind of a deal. Could print all the variables. That would cause the break. Yeah, start it and stop it, then confirm. Also, multitest. Let me just look into this because this is something that I could solve if there's a problem. Multitest pack.match tests. That true. That's exactly what I was thinking there. So this is nothing in particular. Compare all Boolean false. We don't need to compare all. That was more for testing. I built that in for testing, so it forces every comparison to be done, so that you can get a result of what was the best and worst kind of thing. But if I don't tell it to be on, then it won't be on. So if I take that out of there, it's just something that doesn't really need to be in there anymore. For testing, it's helpful. We're not testing anymore. Let's go ahead and run it. "13 times faster." That's what we're aiming for, and it should already be there. Trying to figure out why it's not right now. Welcome, Matter Maker. Now with the possibility of integrating CUDA. Sorry if you have already explained it a couple times, but what did you do? Yeah, Yeah, I can pause to explain it again. So that took 21.235, and it discarded 92.93% of the frames. It's doing everything that it should be. And it is slightly faster than it was, just not 10 times. So, what we've done... What is... What have we done? I'll read from the to-do. I haven't done that today. That's a good way. So, the idea was to integrate simple summed dismissal pretest with pre-calculated LUTs. There you go. Enough said. What we were doing the other day, with that test that's supposed to be a little faster, it was a little faster, but it wasn't, multitudes faster, and we found out that it was slower once we integrated it for reasons. I'll just read this. Comparing the summed grayscale values of each image to see if their total values lie within a range of match is slightly faster. It becomes twice as fast when you pre-calculate the sums of all test images and store them as a lookup table. I should put quotes around that. That means only one sum is necessary per comparison. So what we were doing the other day, it was still as slow, but it was because we were summing both of these images up. And we don't have to, because those images exist. We preload all of those images in the first place. These are the images under cluster truck. We preload all those images, so we can pre-calculate the sum and not have to do that live every time, which meant that we could take out one of those two heavy processes, which would make it almost twice as fast, which we should have seen. And we didn't. We haven't seen twice as fast. But in addition to that, this can be even further optimized if the code is smart enough to hold the sum of the live image across tests that use the same crop color scale values. For example, the level complete test for cluster truck compares the live image to 7 stored images, and there they are. The absolute difference comparison involves doing an absdiff and then summing the resulting difference map 7 times for each one of those images, which means 14 intense table mathematics operations that have to be done. The simple summed dismissal pretest, which is what we're trying to do here, can sum the live image once and pull all 7 of the test image sums from the LUT, costing just 1 intensive calculation, processing all 7 of these with just 1 calculation to see whether it's, whether we should look harder at it. And if we don't, then that should be 13 times faster. And we prove this premise I updated the file that we were working on yesterday that was just the speed test file gotta right-click run it because it'll run the one that you're on. Run this, and we see the results come out that the absolute difference test, 39,000 times. The sum test we were doing yesterday, 43,000 times. Using one of the values as a stored value and just pulling it immediately doubles that because we don't have to do half of the testing. So that's 87,000 times. And then, when we assume that we can do 6 of the tests for just one test, it's suddenly 557,648 times it manages to do those operations in 3 seconds. So the difference between 39,000 and 557,000 is 13 times faster. That's what we should be seeing right now in our code because I've integrated it, but we're not. We've seen like half to 1 second speed increase, half to 1 second faster across this one file that we've been working with. So we're trying to figure out why. I'm going to assume that I think going down this hole and tracing this break, it's correct. It's just correct. It's in the right place. We're outside of this for loop, so we're not breaking that for loop. You don't break an if, so the next loop that we're breaking is this one, which means we cancel this if we did this, and it didn't, go true. If it didn't return true, then we're out within this loop. Yeah, then we just break out of this, and then we go on to the next frame. Take it out, see if it's slower. Missing the obvious on the break. Take it out and see if it's slower. Oh. If we do all 7 of those, That is an easy way to test it. So we do all 7 of those, and then we break out of it. If we don't, then what we'll end up doing is we'll do this once, we'll get a match, we'll do this 7 times for everything, then we'll go back here, do it on the next one of these that we've already tested, do it 7 times again. Yeah, okay. I'll comment out that break, and it should be a fair whack slower. Oh, I'm in the wrong. God damn it. Right click, run SplitRP now. It should be a fair bit slower. Only when we get to the level completes, though. It doesn't look a fair bit slower. The level completes should be the ones where we've got like a match that gets us to do the additional testing on it. That's where it should be doing basically 49. It should be 7 times 7. It should be 49 extra tests that it didn't need to do. That analysis took 21.2. Which would suggest to us that the break wasn't doing anything in the first place. That the break isn't helping us. So maybe, you know, I mean, that was the point of NerdGod suggesting it. Maybe our break isn't doing what we expect it to be doing. It should still already be 2 times faster. 92% of the frames are doing this one simple test, you know, instead of all of this shit. Like, all of this shit is being thrown out for most of the testing. This is like this should make it 7 times faster on top of the 2 times faster that we should be getting out of just this. Could be something about that accessing the table isn't as fast if you have to do other things in between. That's kind of where I'm headed in my mind too, is that I'm not thinking about that, but it is the same concept that there's some other process here that is being done that slows everything down. You know, that there's just something that takes a certain amount of time, and no matter how fast we operate between those things don't go any faster. That's possible. If you disable the advanced test completely, then you can isolate the simple test and then see how fast the simple test is, and if it can be more optimized. That's interesting, little magnets. So if we just don't do this test at all, so I could just comment all this out. God damn it. Cool. So if I get rid of all of that, we do need to replicate the behavior of similarity, though, for this function to continue operating. So once we've got this similarity, if we hand it out, we'll get a bunch of, like, false positives. We know that that's going to happen, but it should be, you know, fast as tits. So if we take all that shit out of there, what do we need to send back? Last proc, if skipped, return result, best, worst, outshot. So result is generated, result true, return true, best, worst, shot. So similarity, what we would want is if similarity is greater than or equal to %, then just go straight into return true, best, worst, shot. Except for we're not generating a best, worst yet. But we don't care about it. We will have the shot. Yeah, that should simulate it just functioning correctly. And then down here is the last proc that still needs to be there doing what it do. If skipped, yeah, we can have all that. And then return result, best, worst, shot. Result would need to be updated. So if similarity is greater than %, well, does result always start false? It does. Okay, that should do it then. And that takes out all of the extra testing, all of the advanced testing, and just does the simple test. It should give us a bunch, I remember in the middle, a bunch of false positives using this. And it's not going, yeah, there's the false positives, and it is not going as fast as I would hope. Video analysis there took 22.271. It was longer. It was longer. And our... What? Wait a sec. What's with that counter? Because look at the value we got out. Uh, 3298, 86.36 absolute diff test skipped. Skipped is set to true in here. And then skipped is never set to false. If skip count plus 1. How do we have anything that wasn't counted? Wait, do/can you just end an if statement with a line break in Python? No. No, it's all done by tabbing. It's all based on tabbing. What? It was longer? How? Yeah. Lots of curious questions here. I have one thing that just clicked in my head that's probably not the case, but that's the multitest. The multitest is called during just sort of the engine, the analyze here, right? So Control F, multitest. So we call that if match, then we split the timer, we add some cursors, we pack things, we log the event, and then we return. Otherwise, and then there's something else, and there's cursors being added, and then there's changing of actions, and there's logging happening. So that's none of that. So this is the only place that testing is done, is in the multitest. I was just, thinking maybe outside of multitest I had another test that was running, but no, this is where all of the testing occurs. So how the fuck was that slower? Let's run it again. Maybe we got a fluke? Could be that the dump into the faster test, or the better test, allows us to drop out of analysis. But no, it shouldn't, because this is the only analysis that runs. That one took 21.6. So it's the same as it was before, ostensibly. Well, that does limit the problem down to that this method is not as fast as it's supposed to be. For some reason. Or something else is getting in there and making it so that it's not as fast as it ought to be. Add the path of Python, your IDE, and the project to Windows Defender's exclusion list. I got a feeling. No. I have to head out pretty soon, so I will stop bothering you, but do you have a way to show how many frames the faster test passes through? Could it be passing through more frames than you think, or have you already addressed that? Yeah, we've actually put in this in particular to tell us how many frames are being, scrubbed, of how many frames it's allowing to drop through, and it was telling us 92%, and this is another, what the fuck? How is it at 86 right now? It should be 100%. It should be 100%. Because, or 0%, the skipped always starts as true. And then it had to be proven false somewhere. So skipped, F, I've tabbed out the skip. So if skipped, skip count plus equals 1, which means it should always do that. Ah, except for when it returns true here. When it dumps out there, yeah. So that tells us why the skip is not getting through there. Wherever it dumps out because it found the similarity was good enough, then it doesn't count it. Sure. Fair enough on that. But why isn't this just gangbusters faster? I'm definitely leaning toward the idea that something else is a process that just takes as long as it takes. And I'm thinking all that interaction with the UI, drawing those lines and shit on the timeline, everything that's going on with the images only load once every, like 5 times a second, I think I limited them to, or something like that. So the image drawing, it definitely slows things down, but it only happens 5 times a second. Between those times, it should be blaring. And you only draw a line when you find a match, which means there's only like 10, 12 lines draw. Well, I guess it'd be 20 some lines drawn. So those only get drawn occasionally. So that shouldn't be it. There is the moving of the line in the UI. Let's just start taking out some stuff. Let's start with that. The updating of the position of the UI in the video. Where would that happen? When timeline move to scrubbers self.frame count. So self.va when screen draw self.frame count. I don't even know what that is. Draw frame. Is that where it draws the output for that? Let's pull out the update even. Let's just pull out the update and see what happens. Because that's a forced update so that it will display what's happening. Doesn't seem to be doing anything any faster. This should be done in 2 or 3 seconds. If it took 20 seconds, and I'm talking about it being 10 times faster, it should be 2 seconds, 2 to 3 seconds, and it should be done. That video analysis took 18.8, though. That definitely scrubbed a significant amount of time off. I'm going to take out all of the window updates. Well has frames and video got. Everything that happens every single frame that involves updating the UI no longer happens. File open. Analyze. I don't GUI, but can you just not draw until the end? That's exactly, yeah, that was my thought as well. That took 14 seconds. So we're getting there. The UI is definitely a fucking bog. But it should still be, this should be done in 2 to 3 seconds. Not 14. Control F, self.va. VA when. Pop splits, log splits, self.frame rate. I think that happens at the end of everything, so that's fine. I'll leave that in place. That's initializing it, and that's starting its main loop. We got more down here. What do we got? Well, this is for adding the cursors and stuff. which is only, it's happening so few times that it can't be a significant, load. And it's not even being updated and drawn. It's just updating it in, memory space. So that shouldn't be problematic. I'm not going to go ripping that out. What's going on in the main loop of the UI? Well, main loop is just a term in tkinter, isn't it? Is that what I'm remembering here now? So this is the initialization of it. Data in out, open file, analyze. When we go to do the analysis, I think this is just resetting everything whenever we click the button. Popping the splits, add text entries, video player, the canvas. Like, if it's not being updated, then it really shouldn't be a load. But it might still be because tk-enter. If you're going to keep it from drawing, just take it out of a loop and do a processing page and a results page. Just strip out the whole video end of things, like the file open and all of the load processes that happen when... What do you mean? Just take it out of a loop and do a processing page and a results page. Oh, I see what you mean. But like that'll be... We'll deal with that. We got to get it to a point where like it's as fast as it should be. This should be done... When I see 5 seconds, I'll be like, okay, that's probably fine, but I expect to see 3. If it's taking 21 seconds, this should be 14 times faster theoretically. Right now, it should be goddamn... It should be like 12... It's 10 to 12 times faster right now. Let's just look at the thing again. 4 tests and tests. We do the processing if we have to, only if we have to, and we get the shot value only if we have to. Percent is equal to test.match percent, and that's just loading a value into percent. Shape is the shape of the image. Which really could be done once as opposed to every time that we hit this. Because when we're loading this up, we're testing for, did anything change in the processing, including the crop area. So if the size is different, then it would need to be changed, but otherwise it doesn't. So there's shape. It could be defined before, I get that. Color channels equals 1 if length of shape is equal to 2. Like, this could be out of there, too. If the color standards haven't changed, then the image should be the same. These things don't... Like, this is nothing, though. I'm going to put that back where it makes more sense for it to be. There's reasons for it, It just covers bases, and they take no time whatsoever. This is nothing. This is nothing. Similarity equals 100 times the absolute of the shot sum, which is already pre-calculated, and then the image sum, which is pre-calculated and being handed in, divide by depth, shape 0 times shape 1 times color channels. Yeah. You get me, you feel me, dog? I mean, that value could be pre-calculated too, but it's nothing. It's a quick multiplication. Slow anything down. If similarity is greater than or equal to percent, return true best worst shot. And best worst is already predefined here. Best worst 0 to 100 results, and yeah. So that's the entire test. It involves one NumPy sum that we know happens multitudes faster. Test.colorPog, test.resize. These are just values being handed into an array. This is just that being, and then return result, and then it's just values being handed out to a different function. this is fast, this is solid, this is not the problem. It's just got to be that's not the problem. So when we're calling that from the analysis, if a Boolean, if on or off, no problem there. If cur match 0, that's another Boolean. Then add a cursor, timeline.cursors.configure green, and disable. So this just adds the cursor. If we've got a match, it adds a cursor, it gives it a color, and then it disables it so that it can't be dragged around. And then the cycle is set to the opposite, and then we add the information to the log. Like the VA win stuff, it's only going to happen when we've got a cursor to update. It's not happening that often. I could take it all out. I'll take it all out. I'll take everything that's a VA win out. Everything that interacts with the UI. But I expect that it will do nothing. Nothing significant. So last time that we did this, it was 14.1 seconds to process this file. Open it up again. Open. 720 test. Analyze. Was a 14-second test with just the fast test? It was, indeed. So now there's just nothing happening here. And I don't want to touch anything until it's done, even though we can't see the values in the console yet. Now it's done. And that took 14 seconds as well, which is what I expect. You know, it shouldn't take that long. It shouldn't get that much updated. I'm curious that these actually spawned. I guess, I don't know where those are being spawned, but the little cursor markers aren't there. Oh, interesting. Still got the correct value. I mean, we don't have correct values because we're only using the bad test. Just to rule it out, though, yep. And we did. So nothing that's VA win is being, you know, told to do anything from, well, we're in here anyway. But we are seeing that there's a massive, I mean, that's down from 20 seconds, down from 22 when we started to 14. The interface, the updating of the UI is a huge load. And the fact that we can pull away and get down to 14 seconds, I mean, that says that we have made this thing a lot faster and that it was just like struggling under the load of the UI demands. So I'm just saying that there's more time there. That is, we've just made this thing run 150% or something faster. It's like, it's a third of 20 has been removed. Of the 21 has been removed. We're down to 14. So 30%. Could the log in the console be slowing it down? Printing to the console definitely does slow things down. But again, it's only going to do it once, you know, whenever it does that. We could take that out. We could take that out and see. I think just by, like, changing the way that the logging is configured, we might even be able to, in clustercheck.rp, run logging 0. Maybe that was how I set it up. You can find out. Open. Analyze. It's still giving us logging while it goes, but you see how infrequently it prints. It's printing more often now because it's so inaccurate without running the proper test. That's 14.5 seconds, but again, that really didn't accomplish anything. Run logging 0. Let's go see about that. Like, logger. I'm looking for name, action, cycles, results, frame rate, last image, cur image. I'm looking for a function that accepts a value in that tells it how to behave. And that wasn't in there. So let's do this. So run logger in file handling, run self.runlog equals int of settings run logging. So self.runlog. So control F.runlog. If file.runlog So if it's not 0, then we put our images in the place. Oh, is that all that the run log was there for? And if it's equal to 2, then I write the third image. So this was, run logging was just about storing images when I put it in there. Okay, I couldn't remember that. Set that back to 2. That doesn't help us with the verboseness of things. In terms of like log event, print prepends new long as string. So while it's running, what we're getting is frame 380 of etc, etc, etc. So let's look for like did space log event, return that. So who's calling as string, log event will print it. So if I take this out, then we will print less often, not none, but we will print a little less often. Open, analyze. So it's just printing the percentages now. You can see those coming out next to me. 40%, 50% done, 60%. And that was done in 14.5 seconds. So taking out the prints doesn't seem to be making that big of a difference here. So I'm going to put those back. What else did I take out? I took those out. Those didn't make any difference taking those out. I'm going to end up putting them back sooner or later. Might as well put them back now. What else? This stuff is what's stopping us from drawing the thing and what got us to 14.5 seconds in the first place. I'll get out of your hair. Good luck. Thank you, Madam Anchor. Quite a cut in time. We're expecting more after another thing. Yeah, we're just trying to figure out what it is that's slowing it down. I had considered that slicing is... I wonder if it's faster, though, than any of the other methods. I do a lot of slicing of the images in order to crop things and stuff like that. So I do array slicing in Python's version, which means you're actually making a copy. So you're taking the data from here and then making a new variable in memory and writing it over there. That shouldn't be anything that gets in the way. That's copying data from one place in memory to another. If that's not pulling it down. Analyze with an S. You like my with an S? Oh, what the hell? Could it come down to accessing the video itself, like scrolling through the maybe video is like OpenCV's video capture method. There's a limit to how quickly it can move the head on the video kind of thing, and we're hitting the top end of that. Load the video into RAM first. I love RAM. So scrub everything that's in the video, every image. Hold every single image in RAM. I mean, isn't that the whole concept of the fucking, of like this video capture thing, is that somebody's already done that? They've already gotten like there's a file and then I mean, maybe it's not. Maybe it's just accessing the frames on the disk. I don't know. It comes down to whatever it's doing, especially when there are L1, L2, and L3 RAM. Hard drive could be. I mean, what else is in my code? Tell me there's something else. Tell me there's... we'll just go through, like... This isn't something that runs constantly. This is like initialization for video. We get all the information out of it, and then, you know, that shit's more or less done, right? We get the frame rate, the total frames. If end is none, or end is greater than total frames, end equals total frames. Sorry. Total frames equals end minus start. Right, because we're handing that in because I've got my draggables, my mark in, mark out, so the end is the mark out thing. Sure. Total frames, iter frames? Oh, there's 4 matches. Iter frames equals 1. I don't know what that's about. We'll get down to it. Self.frame count equals start. Has frames, frame equals video.read. So, yeah, we get a that and that out of just accessing the video using the OpenCV method, video.set. We set our header to the place that we want it at, which is our starting point. And then file access, generate the... We open this up so that we can use the data that's in it. Resolution is equal to the shape of the frame that we pulled out. If the vid file rescale value is none, and yeah, that's new stuff that I put in there. Master crop left, master crop top, that's supporting the new feature of being able to do analysis within a video file, like if the run itself is embedded in the video, has been edited into a smaller space. Self.curpack equals vid file first pack, just loading things. Here's a loop. Well, we have frames, and video.get cat prop pause frames. I don't know. Well has frames and capture properties position frames is less than end. If it's between the mark in and mark out point, then self.frame count is equal to 10th frames times iter frames, and iter frames is equal to 1. Fuck 10th frames. 10th frames equals total frames divided by 10. So that's for the printing out of the how much we've completed. So it's just for each one, it checks to see whether or not it should tell us where we are and print that out. It's nothing. Frame equals frame, crop. So this is my slicing, where I'm cutting the frame down to the master area. And then we cut it down again, and I said that that's something that we could do to optimize it, is get rid of that. We're cutting it down to a master area that's defined in the clustertruck.rp thing here as the screenshot area, and then we're working within that screenshot area. So this crops it down to that, and then we crop it again based on what's defined in the clustertruck.rp thing for each test, which is a waste of time. But again, I just don't imagine it to be. This could be a thing. Converting color spaces. We're converting the frame after we crop it down to the BGR2, BGRA. So we're going from blue, green, red to blue, green, red, alpha. I don't know why I do that. Let's tab it out and see how everything breaks. Comment it out. It's not making any matches anymore. So that's the reason why I do that. It got done in 14 seconds. Still not the massive increase that we're looking for, so that's not holding us back. Self.raw shot equals frame. So I'm just taking this frame that I've just converted and putting it into a accessible object within, a variable that's accessible within the entire class object. Curmatch equals self.multitest. So this is where we access the multitest, handing it across the test that we need to run and what cycle we're on. And then analyzing the current match is just, it's like, does what needs to be done after we've gotten the results. Last shot is equal to frame, has frames frame equals video read, which moves the head forward by 1. And then frames per second timer dot split. That's a timer, and so that's the loop. That's the main loop. Like anything that's going to be slow, that's holding us down, is happening within here. So we've looked at that. We looked at this, which seemed like it was probable as being something. I'm interested what if I just... Well, it's got to be converted, is the thing. What if I knocked both of these out? Would that work without pre-cropping it like that? Is there a reason why I have to? We know that we're not going to get a lot of matches, if any. But it did manage to find run select, and it did start the run. It's just not matching level completes right now for some reason without being in that BGR space. BGR alpha space. Video analysis took 13.4. We did take a little bit more time off or got really, really lucky with running one that just came in, you know, very, very fast. He's executing the code in his brain and running a profiler on it. Yeah, basically. Running a profile should find what you're looking for. Is that so? Is there a thing that I can just, you know, wrap around it and just run it through? And then it'll tell me where it slows down, because I don't know what one of those does. But taking that out did save us a little bit of time, but not like the massive time. PyCharm has a profiler, apparently. Yeah? JetBrains profiler. Let's put this back in. Let's look this up then. There we go. It's a professional feature. Download PyCharm Professional to try. Okay, well, that was fun, because I have the free version. We'll just keep profiling in my head. That would cost money to save me time. I'll just sit here and waste my time rather than my money. Frames video review, the frame per second timer does. Oh, so everything that happens, like, we looked at that. That actually did save me time, and I can do without that, I think. In fact, do this pawn. See if it doesn't have to be in there at all. At least on this end of things. Like, now it should actually give us splits correctly, because we're doing the BGR2A space. And it looks like it is. Does that save me time while actually giving me the results that I'm supposed to have? Checking every other frame a viable option? Would end screens ever last less than 2 frames? You're right, actually. No, we could do that, but, like, where does that end in terms of optimization, you know? I mean... Looking at every frame is something that it just should do, right? It just really should do it. So that video analysis took 20 seconds. What? Why did that take 20? Oh, I know why. Because it actually... It reduces the amount of things that we have to cut from. If we, you know, cut it down here. So that makes sense. So this is saving us time to a certain extent, I guess. Yeah, so if that's saving us time, then when we tabbed both of them out, the color, the recoloring, that's weird. Do that again. I don't understand you. Like when I took out the color profile, do that again, analyze. Pull an all pirate PyCharm, profile it, and tell you what's wrong with it. Okay. You should put that test video on your GitHub or something. Is it already? The test video? No, it's not. It's definitely not included. Yeah. I don't have any easily accessible test videos. 19.2. That's weird. That's fucking weird. Like, why is it that when I get rid of both of these conversions then... I mean, this, without this crop, then it's doing this conversion across the whole frame. I can see that. I can see why. It makes sense. It makes sense. So leaving both of those in, it's fine. Should run at about 14.5 right now. But, so analyze. Like, we've been looking at the multitest. We looked all over it. I think we've looked at analyze too, but I don't think I looked real hard. So we'll look through it. Cell cycles, Boolean. Yeah, we already looked at all this. Then you got the cursors. We took those out for a minute. It didn't really help. It didn't make a big difference. Log event. Because that's calling a whole slew of things. But if I don't log the events, then a lot of things aren't going to happen and aren't going to be right. We'll try it, and we'll see if it, just crashes on expectations of receiving log events and printing them out and stuff. Yeah, go ahead. Yeah, we don't have any events coming through now, because we're not storing them, and that should mean also that we don't have any information to generate anything off of. But we did get the lines and everything. That took 13.3. This might be, I mean, we've looked at every damn thing at this point. We'll just Control-Z your way through this. This might be a limitation of accessing the video file itself. How quickly can we move the frame head forward? I mean, what else is there? The UI is a huge fucking load, apparently. Enforcing these updates, big deal there. If I left both of you on and just didn't do the update, will we still get a 14-second-ish kind of a time on the processing here? So you're technically doing the thing, but it's not actually being updated, which means it's not having to be drawn, so it shouldn't actually have, an impact in timing is the idea there. Each frame check is independent, so it should be possible. Could you parallelize it? Yeah, we were thinking about that. We were absolutely thinking about that, about, multi-processing, multi-coring it. Video analysis took 17.7. Are you kidding me? Analyze it again. It just seems 3 seconds for updating things that don't actually get drawn. TK enter. How bad do you suck? But yeah, Theremin, by the way. We were definitely thinking about that. But this, yeah, it took 17.8 there. So even sending the draw frames through without updating it is a problem. Well, that makes sense for the draw frames. I'll bet I could get away with this one, though. This is where I'm at this point. I'm in that place where it's like, I don't know where to go, so I'm just going to keep tinkering with shit. I'm coming to a better understanding of everything. But drawing the frame is, there's a process involved with keeping these frames running that is way beyond what you would think. In order to have the video frame drawn to this object in TK enter, I have to take the frame, process it to something special that TK enter can deal with, and then resize it. It's got to be rescaled. It's got to be color correct, or it's got to be processed. And then the drawing method, it's all a bunch of slow shit, and that's why it only updates a couple of times a second, was because this was actually a significant slowdown to do that. Taking that out alone, we're down to 13.6 seconds. Let's put the update back on and just see, see how much we lose from 13.5, 13.6. Run it. So now we should see it running, but we're not updating that frame. I definitely think it should just be a processing screen. Yeah, just doesn't feel as good, does it? That took 15.4. Wow. Wow, the better part of 2 seconds just to, update the fucking UI across this thing. 13 seconds for one level means about 2 minutes for a whole run. At 720. Yeah, it's a huge improvement, isn't it? Alright, so let's take the update out, the manual update. And I want to put the actual test back in. I want to put all this stuff back. You know, let it run the way that it's supposed to be running. The code is unreachable. You're right. This isn't supposed to be in there at all. This isn't supposed to be in there at all. Because that was put in to support the change to that. Was there anything else that was like that that I changed in order to support how we were doing what we were doing when we were doing it? I think we're okay. Okay, so this is back to the way it's supposed to be, but it's not going to update the UI. Run the test on the 720. Press undo a bazillion times. For 2-minute process bar, it is good to have something graphical to entertain the users. Okay, so that is, did we get correct results? We did. We're back to correct results, and that took 14.5 seconds. So difference of less than a second, basically. You guys can see that, can you? Video analysis took, you can't. I hate that I've got myself positioned in just the place where, like, the most useful information is coming out in the console, but could you get the UI to update on every other frame half the time save? I could, yeah. Yeah. Could force an update once every 5 frames or something even, too. But let's leave it like this, and let's go ahead and do a process on... Well, let's do the test video. This is the 1080p one. 1080p was running at 70 to 90 frames per second, I think. No, it was more like 90 to 110. But it basically meant it was doing about a second and a half's worth of work per each second. So it was pretty fucking slow. Process the whole thing? Don't process the whole thing. Get you down to just the run. As though I were doing it to get an actual reading on the run. So there we go. Analyze that. See how long it takes to do this one. Are you going to push these changes today? Just wondering. I don't know. Hello, Derek Gregg. I don't know because this is a whole new branch that we're working on right now. Yeah, I haven't decided yet how I'm going to handle that. Because there's the rebuild branch that I could push some changes to that were made before I switch it over to a pure video analysis thing. I think I will just, you know, push the whole new branch. But it will just be the code. I'm definitely not going to compile it at this point. Optimization branch. And they're two completely different things, too, you know, because the other one supported live running and stuff. So doing that analysis, the video analysis, it says... I'm not sure if you can read it. I'm just going to move it up. The video analysis. Oh, thank you for the host, Derek Gregg. The video analysis took 56 seconds of 1:39. That's pretty decent. A minute for 1:40 at 1080p. I try and do, whenever I can, I do it in 720, because it handles 720 very well. So if we were to take a full run in 720, I go to downloads, I do that one we've had. I will scrub this down to just what I would do if I were actually doing an analysis on this video, because I've done it recently. and we'll see how long this takes. So that's fine, and analyze from there. See how long this takes. And since we don't have the little bar moving across anymore, we'll be looking up here for when it tells us 10% done. Which should be around now. There you go. But we're hitting some kind of ceiling though. We've hit some glass ceiling on these processes, and what's been really good about this is that we've gone through my code now to the point where like I feel very familiar with my code again. We've looked at everything and I'm happy with the way that it's like structured and what it looks like, at least in the engine parts that we're looking at, you know, the main core of everything. Very functional. We tried taking out logging, didn't seem to make a difference. The UI, taking that out, suddenly made it 2/3 faster. So we've got to assume that we made the program itself faster by implementing this method. We made the engine faster, but it couldn't go past, you know, the demands that the UI was putting on it. And then when we pulled the UI out, it was able to go that much lower. Make a checkbox for frame updating in the UI. That's a possibility. Have it as an option for people. You can turn it on if you want to see it processing, if you think that's nifty. But if you turn it off, it'll be done a lot fucking quicker. Yeah. I think the like for the updating of the UI, I think we ditch the showing the video moving concept. It just takes too long to do that. But what we could do instead is as the analysis is being done, it could actually like create a canvas. It could start placing images of the run that it's using to be like, this was the, you know, this was the level complete screen. It could basically be showing you what gets built in the run log directory while it's running. And then it would only do that when it found a split, which will take it will take process time, but it'll be, you know, if there's 90 splits in the level, and you're only generating these two images, like the in and the out, just show the in and the out, then you know, it won't slow down the overall processing. Please waste my time processing X. Slow next to the box in the UI. I'm definitely on board for the idea of just getting rid of most of the UI component here. In terms of like the display and shit like that. I need to make a really good timeline. I need to make sure that I gotta fix the scroll box. The UI is the biggest headache. Good compromise, showing the split screens and have it as an option. So that took 3 minutes and 21 seconds in order to analyze a 28-minute, 44-second run. And 28-24-067. 28-24-067. Yep. And 49-39, which is 27-21-270. 27-21-300. But you say it's 49,239. You say 300, I say 270 in my notes here, but we agree on the number of frames. That will be because I fixed the floating point error. I fixed the floating point error, by the way. The frames per second calculation on the floating point error. It rounds it now to 2 decimal points. So that means that now this video is 30.01 frames per second instead of 30.0007519, etc. So yeah, it'll register as being a little bit slower, but that's correct according to, you know, it's not rounding error shit. So that's good. That's not bad at all for Python, in my opinion. The speed? Yeah, I'm impressed by that. 3.5 minutes for a 28-minute video file, analysis, and all that kind of stuff. It's not bad, but it ain't the 10 times that we should be getting. And I'm just like, where's the problem here? Because we can do this speed test over here and prove how much faster it is to do this, which means something else is getting in the way. That's consuming time that can't be gotten back. You know? It's like if something takes long that goes in the middle of it, and then we do that test, and that test is way faster. Way fucking faster. All of the testing is way faster. But it's got all of these big chunks in between it. Like, we still shrink the test time, and the big chunks would be there. It's as though we've got something that is almost time dependent, that's always going to take a certain amount of time. And it could just be that I've got a user interface at all with TK-enter, that I'm invoking a user interface. That worries me. I'm not, we're not updating it manually, but I don't know with Python and TK-enter. I don't know what the fuck is going on that end of things. The UI over here that I built. Show a little bit more space here so I can scroll along. I mean, if I'm not updating it, telling it to update. The other thing is, like, typically a UI is put into a parallel situation. It's threaded. I don't think I've ever threaded my UI because it's always been like a placeholder, and I didn't understand how I was supposed to, initialize one and the other, and I just, like, slapped it together and that kind of a thing. But maybe if I threaded the UI properly, maybe that would get it out of the way and it would behave correctly. But I just don't know how. I've seen the code used elsewhere, but I never looked into it. I was like, I'll get to it later. Maybe just generate a report page after tests and just have a browse box come up when you open it. Don't invoke TK whatever until after the tests. Yeah, the problem is, I'd love to just take the UI out entirely, the GUI, but it's pretty fucking integrated here in how I think. I mean, we can take out all of these calls to update, which we did before. How do we start this thing? Engine equals engine, and then the engine initializes frame rate log enabled, the VA win video analyzer, and then VA win main loop. This is a deep hole if I start doing this, but if we just don't invoke any of the VA win stuff, I expect to do this, and then there's going to be so many things that are embedded and expecting that there's a thing that's, and then the other, and they make a call to a da-da-da, and then underneath that it makes a call to a da-da-da, so forth and so on. And take out all this VA win noise. And then up from the top. Well, search. Just use the search. See if there's anything nested under the logging class or something that that works with VA win. Looks like that takes out all of the VA win stuff. Now that means that when I load this up, I want to call to the file that I'm going to open directly. So skip county is engine, and then we would usually use file open, and that would call to video, right? And then I say on video the path and nothing else, and it'll pop it open. So if when we initialize engine, we do, after started and ready, we call self.video, and then the path that I need to give it is what? SplitRP. I mean, I should just be able to tell it that. 720 test. Play. Seems to be working. I kind of don't want to rephrase or move things around right now. Until it's done. Took 14.8 without even having the UI open. So apparently as long as we're not updating it, then, you know, it's fine. It's not making a difference over the analysis times. So now we know that it's not the UI at this point that's slowing it down. As long as it's not being updated, good. So now, you know, all of the things that I just did, if we could just have not done those. Yep. We're back to it. All right. That's what I'd expect, says Theramon72. Theramon. Theramon! Gotta catch him! Let's take another live stream break and come back and kick around and see if there's anything else that we can come up with, because we're hitting the bottom of something. We know it's not in the user interface now. We've looked at like the run logging and taken that out. It wasn't that. Maybe we could put some timers, wrap some timers around the various like calls in like the main loop and see where the bulk of the time is being spent. Maybe we could just wrap a timer around the actual analysis and a timer around like, I don't know, moving into the next head, the next frame of video or something. There's something in there. Maybe this is just as fast as it can get for reasons that I can't conceive of. But maybe we do something like that. I like the timers idea, says Nerd God. Yeah. Gotta use a profile for that. Just join the stream. What have I missed? What seems to be bug? Timers are good for debugging. We expect our program to be Nano Sirena. Nano Sir Ina. We expect our program, which, since I am going to a break, I will show you, and then you can decide whether or not you want to hang around across the break. Our program runs and does an analysis on speedrun videos in order to give us the timing back. And I have optimized it with a method that should have made this 10 to 13 times faster. And what it has made it is 1.35 times faster. It's well, maybe that's not correct, but it's not even twice as fast. It used to take 22 seconds to do that, and what it just took to do it is 14.5 seconds. So we saved a lot of time, but that was actually mostly gotten rid of by telling the UI to stop updating as it was doing its work, which is why nothing happened when I clicked on it. So yeah, we're trying to take every little bit apart and figure out what the hell it is that's sitting on the chest of this, sitting on the lungs of this program, now that I've optimized it in a way that should be making it 13 times faster, and what we've gotten is, you know, not even twice as fast. It's close, though. It's close. You can import C profiler package to get a profile to work, it seems. The break removal show. I'm going to play with the timers. I've never used a profiler before. I don't know. I don't want to figure something out live on stream that I've never done before like that, where I'd have to wrap my whole program in it and then see what's going to happen. It sounds like, you know, if there's a website that I could just copy my code into. It's not that easy. Should just be 3 lines of code. Well, we'll see. We'll see when we come back. But I feel more comfortable playing with just timers. We shall see. And I just don't know what a profiler would even give me back. What the hell is that? Windows Ink Workspace? We're going to take a live stream break. 7 minutes. Go take a pee. Think about it. You know, you've seen the code. You know what it's supposed to be doing. You know, to some extent, I guess. But think about it, because I'm going to think about it too. Step away, grab a snack, grab a drink, take a pee, leave a cue, insult an R, and we'll be back here in 7 minutes. Don't go anywhere. Pulling that out. Hello, I am the Ronan Ballin, and welcome back to twitch.tv/Ronan Ballin live stream. We're coding! We're coding! Yeah! We're coding. Welcome back to the stream. Let's see. Python-MC profile SplitRP.py seems to work to run a profiler on it. Python-MC profiles or SplitRP. So this would be something that I pull down as a package and... yeah. Shall we jump through those hoops in something I've never done before? I mean, the BMA dev is definitely going out of your way to help me out here. Maybe I should give it a chance, huh? To be honest, I have no clue what you're saying, but this is very good background noise. Hey, you know, that's what I'm going for. That's what I started 6 years ago on YouTube to do. Be background noise for your life. Trying something new is always fun. We can give it a try. So we're looking for C profile. Is that what it's called? Or C profiler? Let's see if this is something that comes down in this kind of a package. So if I go to, it's been a while. Is it just under settings? And then project structure, project interpreter, build execution deployment. It's been a while. Yeah, no, these are my packages that I've installed. So if I were to just be like C profiler, is this BMA dev? Does it look like I'm doing something that makes sense? C profile graph, Python MC profiles, pycopy-C profile. There's always a number of variants, and it's like, which one is so C profile V? An easier way to use C profile. pycopy-C profile, dummy C profile module for pycopy. Is this something that I need to download separately and then install? MicroPython C profile, dummy C profile module for micro. It's built in. Not even a package. It's just built in. It's just there. I can just do a thing. Okay. Now then I need to know how to just do a thing. So is that going to be something that I can run from like the console down here? I don't usually interact with the Python terminal or Python console. Something I could do here? Let's see. So, or it would be terminal, wouldn't it? I'd do it from the terminal. Running command line, I think. So this potentially is, yeah, exactly what needs to be. So if I Python -m C profile SplitRP.py, yes, let's see if this works. I don't know. Okay. File open. What? So do I just go through the motions? 720, analyze. I don't know what I'm supposed to be doing or not doing. You go through the motions. It did its analysis. It did the thing. You should have a .prof file. And then close it. Hey! Alright, well, it certainly listed a number of things. If I scroll up, at the top, I presume it'll tell me what this data is about. Wow, there's a lot of it. That's all the way up. That's a lot of... It's not telling me what the data is about. Or maybe it just scrolled so far that it doesn't... things and stuff. So we're looking for big numbers, I guess. If not, add O splitrp.prof to the command. So the idea would be then we've got a file here. Should have a file. Refresh. Under splitrp. Highcast. Let's just look for a star.prof. No profile file made. So then add -o splitrp prof to the end of it. All right, so we're in terminal, still in terminal. If I go down to the bottom and I say that again, -o, so output to split SplitRP dot prof. It starts it up. We go in, opener, 720 test, analyze. Then you can pip install snakeviz and snakeviz splitrp.prof to visualize that data. Okay, getting deep. I don't want to drag anything. If I drag the window, oh, well, I probably can't because it's not updating. So that's it completed. We close it down. It does that. We go into SplitRP and refresh just in case. Still no. Let's see. Star.prof. Prof. Okay. Well, maybe it's not. Maybe it's in a directory higher. Maybe it's not stored under PyCharm projects. If it outputted somewhere, I don't know where it outputted. We could do it again. And this time give it like a very specific, you know, all this, basically. Slash split rp dot prof. See if this gets her done. File open. 722 to test. Analyze it. $2:00, second beer of the day. Close her down. And then see if we got something now. Refresh just in case. I'm not seeing it. Star.prof. Nothing. Yeah. -O might need to be before the file name. Oh, that would make sense. Nerdgod also suggests using a program called snakeviz so you can analyze it visually. Okay. That could make sense there. So -m C profile -O, and then you can't actually do like a selection from the terminal, which sucks. Take you out. But I would let's do it all again, just so that we don't end up doing it an extra time. So you there, and then paste in there, and then slash splitrp.prof. See if that loads it. Okay, well, it's acting like a thing anyway. Open you up, analyze. Ba-da-da-da! Should I just turn the music back on? And we're done. Hey, this time it didn't output, which is good, you know? It suggests that it actually made a file, and it did. Okay, let's... My Notepad++ has a lot of things in it. It'll come up over here. Okay, that's not readable data. Cool, good. No, don't worry about that. So we will need something, huh? Stick to the man, please, if you do it. From the same console, run pip install snakeviz. All right, pip install snakeviz. Successfully installed. Looks good. Then what? just reading and snakeviz splitrp.prof. Right, so just straight from here. Snakeviz splitrp.prof. Okay. What are we looking at? So I presume these are going to be the longest processes. represented like this, and then we got the smaller ones and things and different, I don't know, what built-in methods, built-in executables. So this is actually representing everything. And then this is the module, the init, the main loop, analyze. Analyze takes 16.8 seconds. Video is 16.8 seconds. These are both running. So we want to see like the things that are happening in these, I suppose. The read of video capture objects is 12.7. The method read. That might be it. It might be just the grabbing of the frame is the slowest thing. Is everybody, am I crazy to be reading it that way? What do we got over here? This is convert. Takes 1.07 seconds. I'm looking above us now is where the text is for that. Convert. If I click on it, actually, does it? It gets lower. And then tells me the thing. So if I reset the zoom, that takes me back to here. I'm getting it. So video capture, it's just the fucking read method for 12.7 seconds. 12.7 out of a total, it was open for 23.4, but the process of analysis was going for 16.8. 12.7 of those seconds was it reading the frame from the video file. Am I wrong in that? That's what we're seeing, right? So the actual analysis took 4 seconds. 4.1 seconds. Yeah? Pro tip, your coding won't have any trouble if you blow up your computer. Hello, McQuack. I like how we could see the W being typed in the overlay. Huh? CV2 video captures hogging everything it seems. Yeah. Glad I could join the genius programmer cracking the algorithm that will change the world live. Hello, Dragon Age 3 Inquisition. Well, my code's sound. I don't know who the fuck wrote OpenCV's video reading process, but apparently I'm going to have to write a new one because it's shit. Click one to see what takes you to the table. Tags what it looks like. So that's what it looks like to me. There's other stuff as well. RAM disk time. It definitely looks like file access time. You have a WASD overlay. Oh yeah, I do, don't I? It doesn't need to be up for this, does it? Yeah. Like, so I would love to see the analyze. How do you break down? Yeah, fucking video. Video capture, yeah. What do we got here? We got convert. You're just an extension of video there, I guess. Multitest. Multitest, where the actual testing takes place. Where all of the fucking image, I've got it down to less than a second. That's what we were working on today. Less than a second of the process is necessary. The actual analysis of the images. 0.9. Try other styles. I'm actually, this is working out fine for me. If I go back to that again, what was it? It was under, I was in under analyze, and then over here, we've got the multitest. We've got CVT color operation, only took half a second worth of our time. Move to? I'm not that concerned. Generate, I'm just split, analyze. Wow. I mean, so my work is great. My work is excellent. The actual test itself takes less than 1 second out of the 14 and a half that it, well, 16.8 apparently it took to run this time, but less than 1 of 16, and 12 of it is in the read thing. Load images took 1 second. Yeah, but that's done right up front. That's done, first and gets it out of the way, but sure, I suppose. Cumulative time of IM read, 0.8. I mean, this is our problem. That's our problem right there. Huh. Okay. So CB2 video capture objects. If I did load the entire video file into memory beforehand, do you think that it would actually be able to get it into, like, an array table faster if it were just doing that, reading all of it into memory? Profiling is neato. It is. Video capture is blocking. Maybe, but aren't we concerned about memory use for longer runs? I suppose. Could do it in chunks or something. I don't know. What's this? Faster video file frames per second with CV2 video capture and OpenCV. That's what I'm using, right? Hang on. Like, we're using OpenCV for this. It's opened in another thing, but it should be down here. So is that like an article about how to optimize it, how to make it work faster? So we would be working in video, and then cv2.video capture is what I'm doing. Work with a video function, found that reading frames just felt slow and sluggish. I've been there. I know exactly how it feels. Why is that? Eternity for it to do the read method. The answer is almost always video compression and frame decoding, depending on your video file type, the codecs you've installed, not to mention, etc. and so on. Computationally wasteful, and there's a better way. In the remainder of today's blog post, I'll demonstrate how over 52%. The video capture object. Then you start a loop calling the read method to pull the next frame to the video so you can process it in your pipeline. The problem is that you're both reading and decoding the frame in your main processing thread. By moving these blocking I/O operations to separate thread, maintaining a queue of decoded frames, we can actually improve our frames per second processing by over 52%. Okay, so the slow, naive method to reading video frames with OpenCV. Wow, importing a lot of shit, including shit that I don't use. Argument parser, add argument. The stream, CV2 video capture, FPS equals FPS start. Lines 2 to 6 import our required packages. Parser command line arguments. Like, I don't know. I haven't had to do all of this shit. And then, while true, grabbed frame equals stream.read. Yes. If not grabbed, break. Sure. So that's where everything's happening. And then your resizing, your converting color, your NPD stack. Resize the frame and convert it to grayscale while still retaining the 3 channels. So frame is equal to NPD stack. It gives you the 3 channels. CV2.put text. Okay, so if I ran that, then it would show it with the slow method thing on top of it, and sure. So where do we get to the part where it's like, this is how you do it better? Using threading to buffer frames with OpenCV. Since the read method is a blocking I/O operation, we could obtain a significant speedup simply by creating a separate thread from our main Python script that is solely responsible for reading frames from the video file and maintaining a queue. Since Python's queue data structure is thread safe, much of the hard work is done for us already. We just need to put all the pieces together. Let's review the code so you can understand what's going on under the hood. From threading, import thread, sys. If sys.versioninfo greater than equal to 3.0, import the Q class from Python 3. From Q, import Q. Otherwise, import the Q class for Python 2.7. Else from Q, import Q. So, because of a change in capitalization, they had to do that. Careful with your languages when you're updating them, people. We can now define the constructor to file video stream. So we're creating a class file video stream, and then the init is going to take a path and a queue size. Self.stream equals CV2, video capture path. Self.stopped equals false. Self.queue equals queue. Max size equals queue size. Okay. And then to kick off the thread, we'll define the start method. Start is, you call it, it creates a thread. self.update, args none, daemon equals true, start. So this is just for threading, for multi-threading. That's what you need to do to start up a thread. Faster video file, frames per second. So define update. While true, if self stopped, return. If the thread indicator is stop the thread. Otherwise, ensure the queue has room in it. If not, self queue.full. Then read the frame. Grabbed frame equals self.stream.read. Grabbed frame def update self. Yeah, no, that's correct. Okay, I get that. You're just forming a list out of it. Yeah. If the grabbed boolean is false, then we have reached the end of the file. Yep. Self add the frame to the queue. Self.queue.putFrame. Okay, that all makes sense to me. Like, so far, this is actually sticking. I'm not just glossing over it because it's like, I don't know. No, it's actually all making sense to me. The read method will handle returning the next frame in the queue. So read return self queue.get. And I presume the queue class that we're using here just automatically has its own internal head, and so you can just ask it to get and it'll move it forward. Faster video file, let's see. Define more, return self.queueSize. What? Create a convenience function named more that will return true if there is still more frames in the queue. So return self queue.queueSize greater than 0. Is that true or is that false? Got it. And finally, the stop method is just, it sets a value to stopped, and then that's the one that we were checking from before. So the faster threaded method, put all the pieces together, enjoy a faster threaded video file with OpenCV, open up a new file, name it readframesfast.py, and insert the following code. So we're importing file video stream from imutils.video, imutils.video import FPS. This I'm not familiar with. What is this package? Is that built in? Is that something to add? Is it something that he's using because of what he wants to do? Is that the code that's in this thing that he just wrote above there? We'll see at the end, I suppose. So, argpass, argument parser. This argument parser shit is just unnecessary as far as I'm concerned. Starting video file thread, and then FVS, the file video stream, video.start, time.sleep 1.0. So isn't sleep a blocking process, though? Like, the idea would be, but that's happening in its own thread. So he's giving it a second to fill the queue before we start doing stuff? Is that the idea? Start the FPS timer. So he's giving it a second. So it's a blocking process, but the file video stream is happening in its own thread that isn't blocked by the sleep. I got it. So that's the code I just read. So basically he's saying write this in a different file and then import it as opposed to just putting it straight in, which is what I'll do, is make a class right there and then call to that class. Import our required packages, imutils, and blah, 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 blah. Faster video file, what do we got? Well, fvs.more, so there's still something in the queue. Frame equals fvs.read. And then we can do all of this shit that, his processing, but our processing will replace, and then he's showing it and he's updating and whatnot. Okay. So that's an improvement of 34%. The actual frame throughput processing rate is much faster, clocking in at 30.75 frames per second, an improvement of 52.15. Sorry? 31 seconds of video. Frame throughput is 30.75. Alright. Okay, I think I get it. You didn't do that thing where you conveniently put all of your code in one spot at the same place at the bottom so that you could just copy it after you understand it? Is that what you didn't do? Cool, thank you. Thank you. Like, is this represented somewhere, or, as a full thing? Or we're up to the slow shit, right? Yeah. I like that it's here for teaching and everything, but by the time you're done with it, I would like to have the whole deal. So that I could copy it in and then just make changes to it. He didn't do that, did he? Bastard. So I'd have to copy it all individually. Does it even copy? It does. It might also somewhere be in here. I remember glancing over something that said, you know, I've set up a thing somewhere. Just a downloadable, maybe, somewhere? Funny, now I feel stupid. Excuse me, sure. You should make it easier for me to plagiarize. Yes, absolutely. You know, you've established a generic method for improvement, then it shouldn't be this hard to like share it. We'll be using my IMUtils library, a series of convenient functions to make image and video processing operations easier with OpenCV and Python. So if I go to your library, see? Utils, contours, convenience, encodings, object. I don't know what it's going to be in, though. And I don't want your whole library. Does he say where these things exist in his deal? This is what programmers are like, you know? Like, let me show you how smart I am. And now, bye. Yeah, so that I don't have to redo the work you've already done. Where are you going? Asshole. If you don't already have my music, previously installing, so I could just install IMUtils like that. Says a programmer. Yeah. Yeah. So, that's why I can say it, you know? I can criticize assholes. I am one. Import FPS, but we've imutils.video fps.py. Alright, so we can actually just, there it is. That's what I needed. So let's go down to the finished, like the okay, and now here's how you input file video stream and you import FPS from video, but he's also importing the full tool set. I don't know that this FPS is something that I actually need, but the file video stream is the thing, right? So file video stream.py. So this is the threading, the sys, the CV2, and time from QImport. This is what we need. Okay. How do I download through this piece of shit interface that was made by programmers? These assholes. Go to file. What? What? Bruh. Can I just download the file that I want? Can I do that? Man, GitHub Dark is nice. Click raw. Right-click raw. I don't even know where the word raw is. Raw. There it is. Raw. Alright, so save link as. And SplitRP. Move you over here. Yeah, okay. You can just be there. File video stream.py. Show in folder. And it's there. So we start with that. So back into our program. And get me out of that. That's just scary shit. So now we should have under SplitRP, if I get out of images, file video stream.py exists there. So if I go up, and, well, we're going to copy over his code for this deal, which is, I think I'm really only going to need that. I'm going to copy what I want, not all of it. So we're at imutils.video import, or rather, it'll be just import file video stream, right? No, it'll be from file video stream import star, actually. Well, no, we can just do file video stream. That'll work. All right, so that gets me that object dragged into here. And then for the sake of, like, loading and accessing and stuff, all of that happens down in video. We're always moving the head from in here. So, back over to his stuff. Where's the Q sauce? It's coming. You don't need any of his code. Just declare a queue with the cv2.video capture results, spawn thread that populates the queue, and then consume it in def video. Or I could just download his and then... World of Programming would have been a lot better if we had an equivalent to Gordon Ramsay that yells at you when you write bad code. It's cold! The plate... Warm food on a cold plate? Like, I'm already importing time, CV2, fuck imutils unless it turns out that his file video stream uses things from imutils, and then I'm fucked. Because I don't want to, it's just a big fucking thing that it's not. AP equals parse, argument parser, we don't need the fucking parsing. This is starting so this is just setting it up. I already opened my own deal, but the FVS equals file video stream, that, and the sleep, I suppose, are things that I'll want. So down to you. Did I import time from time as time, or do I have access to sleep? So if we go over to, let's see if it's under file handling. It's not. Let's see if it's under UI2. Import. We just import time. Good. So I can use sleep without having to, yeah. So what, who, where, sometimes why, occasionally we have why. So video.set, we've got has frames equals video read, video equals cv2.video capture path, except for we're letting his do that now, right? So that's not necessarily necessary. We do video equals file video stream args video. Do I really need this parser here? Let's look at his file. File video stream. This is version info, Q. Yeah, so that will never run, so that's not a problem. File, you give it a path, and then transform equals none and all that stuff. With your args and shit, my friend. With your args and shit. Okay? File video stream will be defined by path. Boom. That's all you need to hand in. .start. Yeah, you better not highlight that. And then there's a time to sleep here. I don't think we need the time sleep. Maybe we need the time sleep. We'll leave the time sleep in for now. I'll take it out later. So that gets it in, but the video is not accessed. Well, is it going to be accessed more or less the same way? So I don't care about the frames per second. I'm not trying to test time frames per second here. Well, fvs.more. fvs.read. Okay, so it's more and read are basically the thing there. Everything else is optional. All right, so more and read. Do you do that? Well, fvs.more. So yeah, sleep. This is just my initialization here. So if that frame rate equals round of the video.get. So I presume then I can do I got a lot of things going on here that go direct to CV2. And now the video is loaded up as file video stream instead, and so it's nested below that. Huh. Still have the quargs in Python. That replaces your has frame loop. Yeah. I'm curious about how I'm going to access these deeper things there. I totally watched Gordon Ramsay's Integrated Development Nightmares. Like video.get, but now I've made video this file video stream thing. I don't suppose you pass, like, things through to the CV2. Self.stream. So actually if I do blank.stream.get yeah, then that should get it. So if I just add the stream in, video.stream.get, that should allow me to access things. Video. In fact, if we just search video. Thank you. Video.streams. I'm not going to just do a hard replace because I want to see them all. I want to, just give me some time. Has frames, frame equals video read. Now, we don't really need that because this is actually going to be video.get, right? Video.get returns the same setup there. No, he does have a read thing, return self_q.get. So, yeah, I can just, use the same code for that, video.read. It looks like it. Video.set, CV2, cap prop position frame. So that's moving the head where I want it. You support that, friend? Because we're building a queue, but we're building it too early, aren't we? Well, I need access to it to be able to use my in and out thing. My mark in and mark out system. I need the full thing, like, available. Maybe I should just use this when we start to do the analysis. Because otherwise, we're going to queue up and we're going to limit the number of frames, and then when I try to scrub them, we're going to end up having problems. I think I like that. I open my own, thing, and then when I go to actually start the, in here shit, I don't know. It would be great if this just worked. And I can always just access it by video.stream to get down to what I want. But this moving of the head thing is, I don't know how that's going to react. Like if I do override his class. So more just tells us if there's something in the queue. Stop. We got running, turn self.more or self.step. So that's just a, tell me what's going on. Read gets us something out of the queue. Update. Just moves it forward by 1. Transform. What is the transform? Did he mention that in here? He didn't. So transform equals none, transform equals da-da-da-da-da, but if self.transform, so it's a Boolean, true or false, frame equals self.transform frame. I don't know what the Boolean is. If there are transforms to be done, might as well do them on producer thread before handing back to consumer thread. Usually the producer is so far ahead of consumer that we have time to spare. Python is not parallel. The transform operations are usually OpenCV native to release the GIL. Really just trying to avoid spinning up additionally native threads and overheads of additional producer-consumer queues, since this one was generally idly grabbing frames. I don't. All right, well, I don't get it. Whatever. But this is just... This just fills it. This just fills the queue. Okay, start. Starts the thread. Yeah, there's nothing specific for, like, moving the head around here. This is why I said algorithmic improvements trump language differences. Speeding up the analysis by 50 times doesn't help with the I/O bottleneck. It's true. It could be argued that something in C would do this queue thing by default. Six to 1/2 doesn't it? I certainly take your point. Okay. I just don't know how this is going to work. If I move the thread around, it's already generated the queue, and then I start pulling from the queue, you see my issue. So the way that I think is safe to at least get started on this is to just rip it all out. I will keep that. No, keep going back. Yeah, no, that's fine. So take that, uncomment that. That makes the video.gets work again. So that all just does what it's doing, and it does the thing, and it does it, and it's doing it. But then when we get to here, when we're going to instantiate this stuff, we'll switch over to the queue, is the idea. I am going to have to, like, have some level of finer control. I might have to, like, add to his class here or something like that. Or I'll just figure out how to manipulate it. I don't know. But so over here, if we make a FVS thing and then args video for the win, yeah, it's going to be path is what it's going to be. And then time.sleep. When it starts up, we could give it 1 second to get ahead of time. That makes sense. And this is going to be... This could just override the video once we've set all of our, things up. Except for what I've done here is I have video.set CV2. Boy, it'd be good if I could actually provide this with the video that I just used. What if this, when I init it, I don't tell it a path to open, but instead I hand it the thing that it's going to use as the stream. Huh? What do you think of that shit? That's pretty smart. So for me, I change this to be, instead of a path, this is our video CV2 video capture object. So if I hand that in, and then I set you equal to the video capture object, then all of the configuration that I've already set up, I've already moved the head to the position that I want, I've already taken all the data out of that, it sets that to the stream, and then this thing will manipulate it from there on. That could work. So then, for us here, we would override our video. I don't think there's a problem with doing that. If I override the video characteristic with sending in the video, dot start, time sleep 1.0, and then while has frames, this is going to replace my while loop here. This is where we get into replacing the while loop. What am I down here for? Let me back up here. We're looking for while fvs.more. So while Cap prop pause frames is less than end. So while video dot more and video dot stream dot get is less than end, the position in the frames of that head, it doesn't, how do I access the return of which, see, we got problems here. We got problems because, like, this is my out. I have to be able to mark when we stop. And this is my check to see if we've gotten to the last frame that I want to be on. You know? So I need to know when we've reached that particular frame number. But the stream object is going to have been accessed by the queue a bunch and shit, I suppose, right? So the head will be moved to a place that we aren't. We need to know when we get to the frame that we get to stop it. Suppose we could count the total frames that we want to move across. It is a linear process here. So if we know where we want to start and where we want to end, then we set it to where we want to start, and then we count the frames that we've processed until it is the start minus the end, or the end minus the start. Sorry, you might be able to keep the frame updates in depending on how much of a speed up this is. This is NerdGod56. What are we talking about? He got it on his own, the BMA dip. Frame updates. Take your point. Read that and see would be the key. Yeah, we could do that, I suppose. So, like, that would be, where are our values then? Because we're defining the start, self.frame rate, total frames equals video.get, the end, if end is none or end greater than total frames, end equals total frames. So we've got our end, and the start, oh, they're just these two? Start and end. Okay. So we can just do end minus start, no big deal. So if, we just need to keep a count. So if, frames proct, I don't know, should never get greater than in this process, but we'll put a greater than just as a, infinite loop deterrent. I love that, an infinite loop deterrent. It's completely unnecessary. We're just gonna spray some infinite loop keep the infinite loops away. A little infinite loop deterrent. Frames practice greater than end minus start. Actually, it's less than. It should just be less than. When it gets more than less than, then it's got to be equal to or greater than. So if the frames proc is greater, is less than the end minus the start, that should keep it from doing that. Finitalizer. So then we need this value of frames proct, apparently. So frames proct. Right, no, you didn't use it. It's frames proct is equal to 0. Yeah, now everybody stops bitching about that. Yeah, I know you don't like that PROCD is a misspelling of something. Go fuck yourself, program. You work for me. SDK. Self.frame count. IDE, you work for me, IDE. Now take some infinite loop deterrent to the face. And then we need to be counting it as we go. So, if let's not worry about that, it's going to do all of these things, right? It's going to do all of these things. Nothing breaks it out. Nothing loops it. So at the bottom of this, we'll say frames proct plus equal to 1. Yes. And vidtimer.stop. Are there any more references directly to video? Video dot. So this is all before we hand it over. And we pass it in, and then while video dot more and frames proct and start has frames, frame equals video dot read. We got a chance that this could work at this point, is how I feel. Both IDE and SDK, really. Half a dozen to one, blah, 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 blah. So if I hit the start button, oh, it's on fire. Oh, God. Oh, no. File open, 720 test. It loaded. So I'm already going to push the limits of this, and I'm going to move that around. It moves around, okay, and moves you around. All right, I won't push it any further. I'll just click the Analyze button. Error. No? Yes, error. So what do we got? Has frames frame equals video read. Too many values to unpack. Expected 2. All right, what are you handing out when I call for read here? I thought it was just passing it all through. No, it just hands back the frame. Okay. So then, has frames, I don't actually need. I don't use it anywhere. Above, I think I use it. Yeah, but that's before we hand it over, so that's fine. Frame. Good. Still on course for this to succeed. Without any expectation of it. It's important as a programmer to never expect anything to fucking work. Or else you just be disappointed constantly. It's working, which I don't expect or anticipate, but it does seem to be still functioning as intended. And it finished in 13.9 seconds. Not particularly faster. Not particularly. Weren't we already seeing 13.5s? You know? 13.9 didn't do shit for us. It didn't do one good goddamn motherfucking thing for us. Jesus Christ almighty! All that work. Was that 720? Yeah, that was 720. Still better than 21 seconds. Yeah, but I was working that way before we integrated his, oh, now it'll be threaded and it'll happen and then we'll queue it up and shit. All right, wait. Let's just look here. Did I do the time dot sleep? I did do the time dot sleep. So it managed to get ahead. That's going to be the problem, is that all of our processes that run are just faster than it can possibly even fill the queue. Right? So we're asking for things from the queue, but the queue doesn't have enough time to fill up. How about this? I'll give you well, it depends on how big the queue's allowed to get. How many frames did you allow the queue to pull in your code here? Queue size 128, so I can change that when we started out. Video, file, video stream, we hand in the video. Transform none, sure, you can stay with none, but the queue size, 128 frames, that's not enough frames for us. Let's do 1,024 frames into memory. And while we're doing that, let's pull up memory. And see how much we end up using here. In fact, I'll just do this. I'll do this, and I'll set you over here. It fits in nicely. Yeah, so 1024, starter back up. Pull you over here, file open. 720 test. Analyze. See if that memory spikes significantly. It's not that significant. And the time savings are not that good. It says 13.757. Fucking everything's in 13.757. You can read that now, right? It's that one right there. It says 13.757. Still no significant benefit. Let's try giving it more time to sleep up front. So we'll give you 2 seconds to sleep. And also, you know, you can process as many as, we'll go up to 2,048 frames. If you can get them in, you fucking get them in, baby. Go. So, file, open. You want more profiling? Ooh, that would be fun, actually, yeah. 720 test, analyze, go. Yeah, I mean, at the end of the day, it's like everything that we're doing happens too quick for it. 13.9. It's not really helping. Run it through the profiler again. Okay. Yeah, I'm up for that. I think that'll be fun. Terminal. Yeah, no, terminal is correct. Do I Control C to get out of this? There you go. Thank you. Oh, yes. Hey, it worked out. So if we do this again, and then open, 720, analyze. Python supremacy, segregation of threads. I think when you changed his file to use the stream, you negated the entire reason for his queue. I said it again because I believe it. Oh, you think so? So he opens his own thing, and then, all right, so there's that. Close that down. So we should now have the deal, and then if I go back to snakeviz.that, pop it open. Well, we got more things going on now. So file video stream took 7.96 seconds. Reset the zoom. Built-in method time.sleep. What? 9.8 seconds lost to it. What? 9 seconds lost to sleep? Am I reading that right? Oh yes, his script sleeps. What? Are you calling sleep in a loop? I didn't think so. Oh, we instantiate video. It runs through this, there's no loops, and then we get into the loop on the outside, time to sleep 2. Control F, sleep. Rest for 10 milliseconds, we have a full queue. I mean, that's fun and all. We probably need to. But sure. Let's just try it without and see what happens. So back over to run. Go ahead and run it again. No rest for the wicked or the weary. Or any of it. The other guy's pie thing did the queue. That would mean the queue is filling up, right? It would. It would. If it actually did do the sleeping bit. Video analysis still took 13.9. Let's look more at this analysis here, because the sleep is a thing that's happening like 7.96, 9.8. That's more time than it actually took to do the analysis. So this is happening at the same time that this is happening or something. I don't think that's actually for real, that there's that much time being lost to it. It might be running, but it's not getting in our way, maybe? I don't know. But I do, you know, I could see that somehow, like, me handing in the stream, I don't know, maybe that undermines whatever it is that, you know, is going on there. I don't think that it should. He has to initialize the queue, or initialize the feed, and then he does things to it and wraps it in the thread. If I hand him one, if I hand his function one that's already done, it's the same as him opening it. It's just I've gotten information out of it and positioned it and, done things with it that I want to do with it. And I don't see why that would make a damn bit of, not a damn bit of difference, is what I'd say. Could be right. Well, hear me out. No! /ban. No, go ahead. The multi-test is taking less than a fucking second, less than 0.9 seconds to do my multitasking, man. Summing is 0.2 seconds. Shaping is 0.26. What about the, what I'd like to know about is the ab stiff. Ab stiff. Do you have readings on the ab stiff? It should be larger. Can I search for search? It's down here. Search abs diff. No matching results found. Is it abs diff? Because we're not running it. That's how infrequently we're running it. It's 4,000ths of a second is how long abstiff takes up. Because we're being smart about it. Yeah. You can open more than one disk.io stream. Here's what I'm thinking. Python and threading and shit, we're trying to do things so fast that it ain't even helping us. We need to go to multi-processing before we bother with multi-threading, but here's what I'm thinking. If I did just queue up the entire fucking thing, the entire goddamned video, if I loaded it all into memory, maybe that's better. We got a queue, it fills completely, there's no limit on it. Is that a thing that we could do? You can have your else sleep. I don't fucking care. What do we got up here again? An instantiation queue size 128. If I told you queue size 0, would that qualify as infinite? Check if there's enough free memory first. Well, we got 16 gigs. It's right there. And we're only using 10 of them. You mean in the program, it should check to make sure that it's not going to fill or something like that. But we'll be fine with this one. This video in particular, I don't know. I'm just going to fill the motherfucker. That's my thing. So what would happen is my question. What would happen if I told you that you were allowed to store we've got a fucking value for this, don't we? Total frames. And if I told you could just store total frames. I don't think it's got enough time to do it. This is what we should do is you load it in, right? While it's sitting here and you're fucking around with this, it could be putting every bit of everything in memory right now. And then you click the analyze button and it's already loaded the bitch up. Loading an entire video in memory would probably melt your RAM 6. You think so? So that took 13.7. We're still right around 14. It just doesn't get time to load the whole damn thing. Hang on. I got a cat crying weirdly. If you're gonna act weird and make me come out and deal with you. You're gonna have to come up and be on the live stream. That's just how it works. So this is Bags. He does not like being manhandled, held, carried around. He's digging multiple claws into my flesh right now, which I'm really into. But there he is. There's my boy. I get you so that they can see you. There's Bags, 1 of 2, the elder brother. He looks happy right now, doesn't he? All right. He's out there just like crying for no reason. He doesn't do that. Crazy cat. You get out of the bridge to the Enterprise and whatnot. I'll fix that. Cat coding percent. Okay, there's 2 interesting symbols that happen when I use my setup for controlling the stream. Huh.
You can't buy me, hot dog man.
How did you train your cat to cry the word weirdly?
Actually, Lady Pawn trained them. she actually did. She's trained them to sit. My cats can now sit. Not necessarily on command yet, that they'll just do it, but hold a treat above their head and say sit, and they know what to do to get that treat. Didn't take long either. My cats are smart. Lady Pawn's smart. I never would have thought to train my cats to sit, but Lady Pawn enjoys it. Just kidding. So, like, I could have, when you do the file open in the UI, we don't immediately call the video, do we? No. So I could try and wedge it in there. This seems like getting far away from the point, though. Like preloading everything in. I don't know. I'm not loving this. I'm not loving this right now. You know, I get somebody else's code in here and it doesn't work at all for what we're trying to go for. It's done nothing for us. I don't know. Maybe it's made it 0.2 seconds. I don't think it's done a damn thing for us having this in place. And I think it's just that, I don't know, my code works too fast and it consumes all the queue and the queue never, like, catches up to it. I delay it by 2 seconds and now we've got 2 seconds worth of queue that we can cram through. It doesn't accomplish. In fact, let's try this here just for fun. Let's give it 10 seconds to load that fucking queue up and just see what happens there. 10 seconds before we even start processing it. 720 test. Analyze. And we'll see. When you're doing live, there's no video access issues. Presumably, you did change. Did change what? Wow, did you see that spike of memory usage? Holy shit, that spike of memory usage. So yeah, it'll fill her up. Wow, will it fill her up? Look at that. Look at that spike. That just about consumed all my memory there. And then because it did, I believe the operating system was like, holy shit, you're almost out of memory. Let me throw a bunch of shit away that you don't actually need. And now we've got an extra gig to play with. It was like, let me close some shit real quick. Yeah. That's good. That's good. So, you know, if it has the time, it can load them up. I'll tell you what, let's just, because we're playing with it, because we're having fun. Where was that again? That I was doing those things with the stuff? Let's give it sleep time of like 7. 7. Aight? Aight. Load this up. File. Open. Give me the test video. Pull it in. Analyze. 7 seconds. Just look at that memory spike. 11.7, 12.5, 13.3. And then it starts pushing it through. And now it has consumed all of the queue. Video analysis took 14 seconds. My code is so fast, it's just a matter of actually getting the video files into process, or the images into process. This is an unresolvable conflict. I cannot pull the images in and decode them any faster through Python, even though my code can blast through the fucking images. We are at, an impasse that at this point we need to do like multi-core for loading in, or for traversing multiple open file handles. Is that what you were, thinking about, Nerd God? I think the video stream thing you did slowed the queue loading down. What do you mean? Not using the stream. Sorry, is there a faster way to fill the queue? Not using the stream. I think the video stream thing you did slowed the queue loading down. I don't know what you mean. Yes, do it again and look at disk usage. I wasn't looking at the disk usage at all. Alright, so close this. Start it back up from scratch. File, open, 720, analyze. It spiked to 10% for a second, and then 3 there. It certainly had a bump. When you change the queue to use the video stream instead of the file, how would that have anything to do with anything? It's just whether or not it opens it or I hand it to it. But at the end of the day, it's still a CV2 video file in the thing. This is in the initialization of this. So when you make a file video stream, the first thing that it does is open the stream. It's just whether or not it opens it from disk or I hand it one that's already open from disk that I got a chance to use and get things from. 10% is nothing. Disk I/O threads. So just open multiple paths to the same file on different, and we could have it run it on different processors. And that's the thing that this method that we've got right here, this new testing method could actually do. Like it's possible that we can go through and identify any frame. Where the fuck is it in my code? We've been doing this for so long. Gen splits principle. What are we talking about here? Multitest here. This version of testing could go through and look at every possibility instead of looking at what are we looking for right now. It could actually test every possibility available and then just mark the places that might be of interest. Without knowing what happened on before. It could this might be a level complete screen, this might be a level select screen, this might be a pause screen, and just mark them all and not even say what it is. Because then the regular program is just going to go through the places of interest where it might be something worth looking at, and the regular test will just go across any area of interest. Doesn't need to be told what it's supposed to be, because there's an order to how these things flow. So it'll start out looking at the first area of interest, which will be, this could be a level select screen. It'll look at it, oh, that's a level select screen. And we drop out of it, and that's when I should start the run. And then it'll skip to the next section where it said, this might be a level complete screen, and look at that and go, that's a level complete screen. So we could actually use, multiple workers in, threads or processors to take chunks of the video file, pre-process them, and say, what's interesting here? What looks like something we might want to look at? And it might be able to get that done in... The thing is, I think multi-processing to engage it in Python takes about 2 seconds to set up the workers and stuff for some reason. At least that's what I read. I've never really got it working successfully on any project that I tried. which have all been revolved around this. But so if it takes a second and a half, 2 seconds just to set it up, it could probably process like this whole video in terms of finding the points of interest. That's an interesting I like that terminology, a points of interest search. First, we process it all with this incredibly fast method that just notes, you might want to look over here, with as many cores as your system can virtualize, and then we send the single-threaded runner through, the areas of interest exclusively. It's an interesting idea, but it's a big fucking idea. It ain't like what we've been trying to do, setting that up just feels a little bit more expansive and exclusive and a big change to code and stuff. You shove the queue in. Let's see. What I'm saying is that other file will do that by default if it opens the file instead of the stream. That was the whole point of the article, I think. You shove the queue in after the file was opened instead of using the queue to open the file separately like the article was suggesting. Shove the queue in after the file was opened instead of using the queue to open the file separately like the article was suggesting. And that gives it time to, like, thread it up and that kind of stuff. My only concern with that, my only issue was that I had to change all of these different things to access the stream directly. And I'm moving heads around, and all kinds of weird shit is going on. When we call video, we call path there. How does this work? I'm just curious. Like, now I don't know. Open. So, open file. Give me .open file. Command self.open file. All right, give me open file. File name equals file as asked. Sure. And then what do I do with it? Self.screen.load video. Load video. So I actually open this thread here. Video player. And this is separate from when we actually do the analysis. This gets opened. And then when we do the analysis, it opens it again from a different thread for that. Interesting. Because, I mean, when it loads the video in, we could set up the queue to start doing it. My problem there is that I don't understand how, like, he's got the queue and it's loading into the queue. I need to be able to move that queue forward by a specific number and say, we want to start this processing at frame number 256 and end at frame number 1832 if I want to. And I don't know how to move the head of the queue system around. And it's not built into his class to be able to support that. I'm sure, if I just looked up Python queue, I could figure it out. Binary search over video frames. Sorry. Can't you do that like you do normally? Like video.set head position? I could definitely, like... I mean, his file video stream here has certain methods. Start, update, read, running, more, stop. That's it. And I don't see anything in here that would override, and pass along things down to the lower deal. But with this queue system, ostensibly the way that I'm understanding it is that you've got the file IO, you've got the OpenCV, object that's open, and then the queue is loading up, just kind of everything in the queue. So I would need to move the queue to where it needs to be. So like self.queue.get put full get no wait queue size. Those are the public things that come up in the list here. None of them look like move it to someplace. Like, I thought put might be there, but that's putting something into it. Item, block, timeout. That's not moving the queue head forward. It doesn't look like it anyway. Get, no wait. Get, and we can use get self block timeout. So we could tell it the block that we want. If the queue fills up entirely with the video, and as we see, that's going to override, that's going to, you know, kill the memory. It's going to be too much to hold. But with this get method directly on the queue, then it looks like I could probably just tell it which frame I wanted to go to and just hand it to the get method as the block that I want to move to. And then it would get the frame from there. But then would it leave, like, the head at that point? You know, the head of where we are? I'd have to search the queue, you know? You were supposed to feed CV2 video with the queue, but you fed the queue with CV2 video. What? The fuck are you talking about? This is the class. It initializes. The first thing it does is open a CV2 video object, and then I've handed it an object that's already open, and then. Why do you think that there's a difference? I don't understand you. Why do you think that there is a difference between handing it an open object that is already initialized or having self.stream equal to cv2.open an object that will be the same thing? Why do you think that's different? Because of disk IO threads. No. There we go. So you think because I opened it outside, like, I've got an IO thread open apparently for the GUI, right? And that starts separately before we even start, like, running our initializations. Then I've got a thread that opens for the analysis so that I can get the information that I need about the video. You want me to hand, you want it to open? Fine. We'll open the thing. Fine. I'll just have a third IO stream going. I don't fucking care. It'll shut you up. Jesus fucking Christ. Set you back to path. You can open your own video capture thing. What gets fed into the queue is directly correlated to the self.stream object fed, and using cat prop pause frames will advance the video and push the frames into queue from that point on. Right! So that's why it worked, because I did this. Because I handed it the video at the start point, as opposed to loading it up with a video where I can't control where the thing is and it already starts filling the queue, which is what's about to happen. Which will be fine as long as we're analyzing it from the first frame all the way to the last frame, but I can't, what I need to do then is interject an extra variable into here where I tell it where to start. We could maybe do that. That's what I'll do. I'll try that right now. Like, start, queue size. Queue size equal to 120, and I'll add you to the end. Start equals 0. And then I'll pass in a start variable so that I can move the head to where it's supposed to be, because otherwise the queue's going to fill up with shit that we don't want, and then we're going to be out of sequence and out of sync with what's going on over here. But I still don't see how it fucking matters whether or not I've done it to this IO and then handed it over, or because it's just going to start. This is when this kicks in, it does all this and then goes into the loop. But, okay, we gave it 7 seconds to get ahead before we started doing it. We still came out at 14 seconds. But okay, I hope that I am proven wrong about this. So self.stream CV2 capture path. We're doing the path again. We're going to start is equal to 0 unless I hand in a start. So over here, global skip count, video equals CV2.capture path. We're not going to open our own. We're going to video equals... I think I'm still going to have problems with trying to do this. This is going to be a, what is it, a file video stream, and it's going to be the path, and then we'll say none, and we'll say 128 just to leave it in its starting configuration to begin, and then our initialization will be start. Start is where it will start, and then what I need is to move that to the correct position in video.set CV2 frames start. So I'll put that into his deal here. So we open it, and then we self.stream.set, and then we can move the head. Oh, hi, Ronan Paul. How's it going? I wish you a smooth transition to second Trump administration. He lost. We're good. Wasn't the point of the queue to open more than one? No. It's not what he was talking about in the file there. It was just to get it into its own thread, separate from the other one. But so now we can open it on the starting place that we're going to want it at. I still need to collect information from it, but I can do it like this. Video file self.framerate is equal to round of video.get. It will be video.stream.get to access the object that's underneath there to get the information about what the frame rate is. Video.stream.get in order to CV2 cap prop frame count. If end is none or end is greater than total frames, yeah, that's fine. Total frames, basically anything that has video dot in it, we need to look at. So video.stream.get video stream to video.read, that's fine. Video.set, that's going to have to be that we don't do that anymore because we've done it already. Vid file access. Res equals MP, well, you're just still looking at the video dots. Anything else should not affect anything, really. Yeah. So video.more, video.read. Okay. Those should be the changes necessary, I believe. Let's give it a try. Starter back up. File open. 720 tests. I won't move the head. We'll just click the Analyze button. Oh, I've still got the 7-second delay, don't I? Shit. Need to take that out. Rudy? Giuliani? Sorry? Oh no, we're stuck in an infinite loop or something. Right? We're not... Just gonna have to close that down. No, wait for the program to respond. Hang on. Can I get to you and just stop it? Thank you. So what did I do? Number one, do I still have the big long sleep there? I've got a time.sleep 7 that we don't need. Video equals file video stream. That doesn't need to be there anymore either for this. Because video is video is video, and it just falls through. Maybe that was the problem. Let's see. File, open, 720 test, analyze. It's not starting. Like, this shouldn't respond, but we should see stuff happening in the console. And it isn't. So setting this up to the start where it should be, let's just take that out. That's the one thing that I've changed here. We can still have the start there. It'll just not do anything. So that'll return that to what it was before. Like, is that a problem? If I move the head for some reason and then the queue system doesn't know what the hell it's doing anymore. I click the Analyze button. Nothing happens. We're still sitting here waiting for nothing to happen. In fact, we're never getting to... the first print here, video analysis, no. It's under video. Yeah, video analysis of path containing total frames at self.framerate now running. That doesn't end up printing. So it's not even starting. Video equals file video stream, path none, 128 start. Sure. Self.framerate is equal to the round of the video.stream.get. Give me the frames per second. and round it to 2. Total frames is video stream get the frame count. If end is none or end is greater than total frames, end is equal to total frames frame equals end, 10th frame, self-frame.count equals start, has frames, frame equals video.read. So print going, print gone. File open, 720 test, analyze. That's where it's getting stuck. We've got going, but we ain't got gone. So for whatever reason now it won't do the read. The path is being passed through. He's not doing the kind of handling for the path that I was doing. His end of things. Have I already processed the path, though, by the time that I access video? When I call video, no, video. Where am I calling video from? It'll be the UI. So it'll be dot video, engine.video, self.screen.file name, and I will have already processed that, right? Search for .file name. File name equals file name. Load video is where it's coming from. Open file. File name equals file dialog.ask open file name select file. So I'm getting the file name directly from the operating system and handing it to it, so that should be correct. There's very little probability that that's not right. Maybe you need that 1 second sleep after all. Didn't I leave it? Oh, I took that out of somewhere and put it somewhere else, right? I had that stuff down here when we were loading it up. Shit, where was that? Sleep? It's got 0.1, it's got 0.1. Oh, that was when I loaded up. So time.sleep. You're right. That's something that I that's supposed to be in there. 1.0. See if that's the problem. If it didn't have time to fill the queue or do anything or instantiate or some other shit. 720 test. Analyze. We still got going but no gone there. It's failing to actually do the read end of this. Return self queue.get, and then the max size queue size 128. I don't know how we broke it, but we broke it. I think the path, that's the only thing that makes any sense to me, is that the path isn't like a form that it wants, I guess. Before I hand him the path, I can print the path, and we'll see what it looks like. C users running Palm, PyCharm project, SplitRP 720 test.mp4. I don't know what else you could possibly want from me. It's open, you know. This is we were handing this through to the same thing. CV2.video capture path. We were doing that exactly the same way. So it's not the path, it's not the transform, it's not the queue size. Those are all set to normal. I'm not even adding in a start thing here. I mean, I am, but I'm not changing it, so it will be at 0. So I guess then it comes down to, well, we took out the part where I move the frame head, so that's not it. That's it. Hey, front slashes. Linux? Linux I? Linux 1? What do you... Pass the path. It works if I opened it my way. I feel that this has just wasted a shit ton of my time to have this end up having this in here, and now it breaks and doesn't work on this side. Did you see the path had front slashes when you printed it, though? You mean here? Where it's still printed? I mean, this is the same data that I was using to open this. I'm literally holding down Control-Z. That stream. No. We undid across what I had done before. So VC object. This it's not working. It's not of help. It has been no additional speed. It works when I hand it in. I've already shown that. When I let it, work the way that it's supposed to work, it doesn't work at fucking all. The path that I hand in the code back here, it's the same fucking thing. It's again, especially Nerd God, it's the same thing with you too. It's like, no, but the same code over there would do something magical and different in the file IO threads and the queue. No, it's the same thing. It's an object of a type. It's being handed over instead of the object being opened at that point and put into the variable. I'm handing you the object and then you're putting it in the variable. It's the same fucking thing. So I'm going to just go ahead and undo this. I said already like 10 minutes ago about the queue. After haranguing me for like 30 minutes about it and getting me to do all this stupid shit, now I gotta go back. Time sleep 10, we were fucking around with that. Like, it's literally of no use. It has been of no value to use this guy's code for what we're doing. So what I need to do is actually go all the way back and get rid of all of his code. And I could pull open a history here and just click back to it, but I think it'll be easier to determine if I do this. FVS, yeah, no. So there's video, that's us. Get rid of his video stream shit. It just didn't go anywhere. Where am I now? There? Yeah. So there, we're back to what this was. Just, our code running as our code. Click the analyze. And see what it comes out with for the times. 13 times faster. What did you do? Parallel computing? Give this man some versioning using get. He did a thing that skips a calculation if it detects that it doesn't need it. Yeah, and sadly, it's not going to be 13 times faster because of the time that it takes to actually, load the file. However, we are at the fastest possible that the file can be loaded. Our overhead at this point is decoding the frames of the file in order to analyze them, which we determined. It's really cool, too. Where is it? Do I still have it open? There. This was the extra thing, but yeah, let's do it again. I liked this. Let's do that again. We're gonna do another analysis here. But so that took 13.8 seconds, the same as whether or not we were using his code or not. We're not using his code anymore. Thank you. Have a lovely day. I'll keep it around in case I end up trying to do something multi-processing, multi-threading. But, so let's do this thing again, because this is neat, and I want AJ to see it. So if we go into Terminal, and I Control-C out of that, and we do a profile. We're profiling the program right now, AJ, so I'll open it up, I'll run a test, analyze. So we're just processing this old video, and we've turned off all of the UI components that update because they were holding us back. As soon as I turned that off, we got 7 seconds faster, basically. So we've now done that process once. We closed down the project, and now I do snake viz. Pops open our visualized analysis here of how it worked, and check this shit out. So the analyze function took 16 seconds. 11.7 seconds of that was spent waiting for the files, the images of each frame to read in. Even cooler is if I find, here's the multi-test. The multi-test took less than 1 second, and that's where all of the comparison actually happens. You know, there's other things that happen in there in terms of like modifying the, you know, the images being adjusted and shit like that, but the entire multi-test takes less than 1 second out of the 13 seconds that it takes to get this in. What have we got here? Array function internals, sum. The sum operation, which is part of our new test that makes it faster, took 0.2 seconds across the whole fucking thing, apparently. The shaping? Really? Just pulling the shape of an array took 0.25 seconds? That's interesting. Is this... Oh, you just zoomed down on a bunch of shit. This isn't all, like, part of the multi-test. This is just shit. Summing there, 0.237. Summing there took 0.292. That's weird. Give me just this. Video. Okay, I'm confused what it's doing now. I wanted you to just show me what was going on in the tests. Move to multi-test. Under the multi-test, I don't understand this representation of things. But okay. Click shaping. Shaping? This one? On the shape, rather? So there's the shape. There's NumPy, core, multi-array, umat, implement array function. I don't know, it's some NumPy shit. Underneath that is the sum, a wrap reduction, NumPy micro functions. I don't know. That's the actual maths. Okay. Dict comp, shape. There's shape shit going on. There's shape shifting is happening there. I'm surprised to see that shape, like, because in the code, we're talking about all of this is happening under the multi-test area here. Control F shape. So shape is equal to mp shape.image, and then if length of shape, so this is like the function is np.shape, right? Or are they saying this variable was acted upon a lot? They're not saying np.shape, they're saying shape. I don't understand entirely, is the thing. What's sunburst? Hey. What is this? This is reduce, wrap reduction, sum. Why does it? That's weird. I don't like that. That doesn't make sense. Maths are cool. Even computers suck at algebra. That's total time, not each iteration, I think. Is dot shape like the lengths of the array? Yeah, it's like the shape of the array, like how many, you know, in an image file, 1920 by 1024 by 3 to store the red, green, blue. So it's the dimensions of the array is all that returns back. But yeah, the fact that it's just saying shape there, I don't know. I don't know. So this is the multi-test, and that was the shape, and we backed out of shape. Array function internals. If I click on you again and I'm in you, and then I look down here, is there more? Total time, 0.1 second for the array function internal shape. from numeric.py, 0.04, 0.03, and then numbers that have to be represented with weird things. So yeah, I think maybe this is talking about like things operating on the variable shape. I don't know. Looks like an internal pi function that just handles shapes. Yeah, except for this one. Like this 2 : shape array function internals. This is the one that takes the longest, 0.1 seconds. 25,000 calls. And then the one that's like directly related to, well, it's from numeric.py, isn't it? I was thinking that was numpy. So maybe that is the numpy thing. That's surprising how long that takes. Because, you know, there's a lot that could be inferred and assumed, and that number doesn't need to be calculated a bunch. If we could make it faster than it takes to load the fucking image in, it would be worth optimizing or caring, but we can't. So, yeah. Yeah. I think we've come to the end of this then for the day. We've done the most that we can. We've analyzed it. We've made sure that we're not missing any tricks. We're losing most of our time to waiting for the OpenCV to actually like decode the images in there. And that, when you get down to it, is fair-y fucking enough. We are talking about, these are MP4 files, you know, these are highly compressed images that have to be decoded in very obscure and ridiculous ways that allow them to be, you know, to pack minutes and hours of video into something that is, you know, a gig or two. So it's kind of fair enough there. Sorry for being annoying. I've been hella bored traveling. No, that's fine. I just, you know, it gives me an opportunity to then be annoying back, which is very entertaining. Whenever I get a chance to yell and be like, God damn it, nerd god, why would it fucking be any different? That's just, it's the show. Is there a better way to decode it? Now, there's a question. Python, decode MP4 fastest. And see if OpenCV is not actually the best that you can do. Faster video processing in Python using... I think that's what we looked at before. Python script to convert it. I'm looking for like a library. Python video converter. We're looking for like a decoder. So Python MP4 decoder library. Encoder, decoder for Python. What are you? Says C++ based. Nerd God, you like it? Isn't it called H265? Or, well, you said 5.6, but you mean 265. Possibly. H265, H264, yeah. There's a lot of different things. FFmpeg encoder decoder, though. That's not necessarily... That's the thing, is when you get into fucking encoders, decoders, Jesus Christ. Like, I don't know, there's wrappers, and then there's the actual encoding of it beneath the wrapper, and Example of decoding a video in an arbitrary format. D.extract GOP. Get a GOP, whatever a GOP is, of current video by setting the start position of 10th frame. Get a GOP of current video using the current position after the last extract. GOP. Extract 100 frames from the beginning of 100th frame. So this would actually just rip the data out and try and put it into memory or something? Because, I mean, it's you can actually use this to just grab it and say, give me 100 frames starting at frame number 100. That's interesting. C++ based encoder decoder for Python 3.5 and NumPy 1.13. Theoretically, you do not need to install FFmpeg for using this library. Theoretically. Example of demuxing. Transfer the coding of a video with an assigned codec. Demuxing would usually be the concept of stripping the audio from the video. And video from the audio, you know, just getting it separate. Example of transfer the coding of a video with an assigned codec. So moving it AVI and then encoding it to an MP4. Fast. I mean, this looks like it's more specifically dedicated to processing and encoding and decoding and you know, changing the type of it, but there's this kind of a thing could be out there, you know. When I was developing for the sake of having SplitRP run live, I did a lot of research into trying to find the fastest library and tested a number of them. Fastest library for getting screenshots from the screen. So you might be able to find out there that there's something that's better than OpenCV is at getting into the file and decoding it on the fly, but also maybe not. Can what you're using even handle HVAC? I don't know what an HVAC is. What are you currently using? OpenCV, yes. OpenCV is what we're handling the MP4 for us. And this didn't give me a great, list of results. Python video converter. Video converter is Python 3 module for converting video files from one format and codec to another. It uses the FFmpeg multimedia framework for actual file processing and adds an easy-to-use API for probing and converting media files on top of it. What if a player, because this is the thing, what we really want to get at is we want to just get at the fucking, the image, the actual frames of the file. So, MoviePy. Python library for video editing, cutting, concatenations, title insertions, video compositing, video processing, and creation of custom effects. Read and write all the most common audio and video formats, including GIF, and runs on Windows, Mac, Linux with Python 2.7 and 3, or only Python 3.4 from version 1.0 forward. Here it is in action in an IPython notebook. Okay. It comes down to how do I find out if there's a faster one and yada yada and so forth and so on. We have increased the speed of this program today from 22 minutes to, or 22 seconds to about 14 seconds. So is that right that that's it's 1.5 times faster? Or is it the other way and I do 14 divided by 20? It's been a while here. 63% speedier? 14 is 60, that's no. I think it's the other way around. I think it's 1.5 times faster than it was when we started. A little bit under that 13 times faster thing, but my processes are faster. We're butting our heads on something someone else wrote. And that, there's going to be a natural limitation to it. You got to decode this video. I think that 2 minutes for a 30-minute run is already okay. A 30-minute run at 720p, which is what I recommend for doing these analyses, is to go for the 720p. It's got a clear enough video file, and it's not in excess of pixels that will take long. So, I think we've bumped our head on something that's going to be semi-unresolvable. It might be able to be whittled down to take a little bit more off, but at the end of the day, there's going to be an amount of time to decode the video. And if what I could think of to try and make it faster would be, along Nerd God's lines, is taking chunks of the video and... No, the best way to do this would be to open multiple streams. Instead of trying to load the whole video in, we open multiple streams on multiple processors, multiple threads, but more like multiple processors, and we pre-process everything. And then we come back with a single thread and go over it linearly. That's basically the best solution I can think of here, because that means that we can have multiple open threads that are transiting simultaneously, maybe. There might be a limitation to that, too. We might just hit the speed of the hard drive. How many things can you access at once as an issue as well? I don't fucking know. But that seems like the only real way to go forward from here. Because then we can have, instead of trying to load the whole video into memory, which will apparently overflow the memory, we can have multiple heads that are scanning across multiple things, get it done in that, much quicker time, pre-processed already, and then just look at the slots. I think that makes the most sense. Totally agree after exploring the other option. Cool. Ronan, we want it to take 1 nanosecond. Parallel computing is a huge pain. Let me tell you, I wish you luck if you try it. I've never had any success. Never had any success. But this is exactly what it's built for. This is exactly how the kind of thing that it actually works for. Because if you're going to do parallel processing, the threads can't interact. They can't need to talk to one another. They just have to do their own fucking thing and then come home, dump their contents on the porch, and then you get to come out and say, okay, I sent out 8 CPUs, 8 cores to do something. Now I've got 8 boxes to look through. And that's why parallel processing doesn't usually help in most projects, because you can't do that. You need to know something about that in order to do this. But this is what parallel processing does best. We were talking about video, we're talking about image processing, where you can just shove images into a raw machine that just cranks through them and does what it's going to do and spits out the results on the other end. This could actually work. It's going to be the first time that multiprocessing has ever worked for me. Oh, future research. Use the free quantum computer from Sweden or whatever. Hey, Paul, and I did a practical test this week on C++, and before doing the test, I had never used C++. Oh, cool. Still pretty sure I got like 75%. Hey, that's a strong C right there. That's fine. Hello there. Hello, Jungle Lion. If you're just showing up, I'm sorry, but I'm spinning down. I think we're done with this. Been here for 5 hours? 5 hours, really? We've had like 2 lives. Did we have a 3rd live stream break across 5 hours? Jesus Christ. Did not manage to hit 13 times, but we've done apparently all that we can do without going parallel processing. So that's what we'll do next. That's what I'll tinker with. Maybe I'll do it on stream. Probably not, because I have no idea how parallel processing, I've never written something that actually worked in parallel processing, so it's probably the kind of thing that I gotta just stare at quietly for a while. IBM has a small one, too, and a guy I know is able to get you access to his if you write him a nice letter with a suggestion. Quantum computing? Maybe it could just, we don't have to do all this video analysis shit. We could just feed in the data about the runner, and the quantum computer could give us probabilities that they beat their PB. And then, I got 69% on my programming class midterms, says AJ. Really? And you making a fucking Minecraft clone in Unity and shit? I guess they don't know. Don't trust the system. Schools are no places for smart people. Yeah, Lady Pawn showed me some Rick and Morty. I hadn't watched any Rick and Morty until she came. That link looked pretty extensive. What faster video processing in Python using parallel computing? Yeah. Is this the same jackass who doesn't put his code in a way that you can get? No, maybe. looks familiar. Oh fuck, it's him, isn't it? No, I will definitely. I will definitely. I'll get that off the screen. Get that off the screen. I'll definitely look at that on my own time and come back to it. So, I mean, I'll tell you here before I wrap it up. Here's what I'll show you what we actually did today. We proved the concept. All right, we proved that we know what we're doing here. So this is the test before we integrated it into a process that also has to get access to encoded frames of video. But speed testing here, this runs the test that we used to do, it can do it 38,000 times in 3 seconds. Then it runs the updated test, it can do it 42,000 times in 3 seconds. Then it runs the updated test, it can do it 86,000 times. And then it runs the updated test 552,000 times in 3 seconds. So what we could test that we could do 38,000 of in 3 seconds, we can now do 552,000 of in 3 seconds. The only problem is the rest of the computer ain't fast enough to keep up. That's basically what it comes down to. But thank you very much for everybody for coming out. I am the Ronin Pawn. And, yeah, probably next live stream, having done 2 programming things back to back and knowing that, like, what I need to do now is a parallel processing dive, I'll probably, if I do that, I'll do it on my own time. And so next live stream, we'll probably get back to Cluster Truck No Ability and try and get that second rank run. No, we can. If I save 16 seconds, I got it, but I won't be happy with that. I want to save a minute. Round a minute. I'll be okay if it's like a 50 and up, but if it's not, I'll be like, I know I can get more time. So that's probably next live stream. We'll actually play Cluster Truck instead of develop software that supports moderators to moderate speedruns of Cluster Truck. Yeah, profiling was cool. I'm glad that I've got that now, and then I'll be able to use it on future programs. So thank you for dragging me screaming and kicking into that. We got it done now. Oh yeah, and Twitch %. You're right, Little Magnets. I had forgotten, at least in this moment, but we hit our sub goal, so we're going to do a Twitch % run. Maybe that'll be the next thing that we do. That's where you guys can fuck with me while I'm trying to do a speedrunning Cluster Truck. But thanks again for coming out, everybody. I will see you next time. Pawn out.